join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
I
would bet.
You guys had Soy Boy on the mic today?
No. What's up, Toy Boy? Go ahead if you want to chime in with a question or something.
Well, Soy Boy wants to say that in the Cavendish experiment, space is bent, and that's the cause of the observed phenomenon.
Well, from my understanding, it's not really an experiment, is it? Because, first of all, you don't even have a naturally occurring phenomenon.
He's saying something that wasn't even conceptualized at the time of Cavendish, though. That's kind of weird, Soy Boy. So can you provide a citation from that paper that says anything about space bending?
I just cited a Wikipedia article.
That's not a citation, though.
Why not?
Well, it's just a link to Wikipedia. I mean, the citation would be the thing specifically what you would like to bring out of the source, which is what you posted.
But it's just kind of all there, though.
You're going to point to it with a citation. You're going to point to a specific part of the paper, right? And you're going to show that to us.
All right, then.
Yeah, if you're going to cite Wikipedia, or Google, why do you even bother? We could just do it ourselves and bypass you. Hey, at 6:15, I just posted something. My friend Alan, who's been in here, and he did How Math Became Reality. He dumped a bunch of stuff on me today, put it in my little debate area, and one of them is this map right here, which is basically what they try to cover when it comes to cell phone coverage and things like that. So when that 14-year-old came in yesterday and said, I can go out into the Pacific and I can get coverage because of satellites above, he was assuming that he could get coverage out in the Pacific Ocean, and he's telling us, ha, 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 I can get coverage. He can't even prove that he gets coverage because, this map right here is an example of what they do for us as far as giving us coverage. They don't cover the ocean. I mean, it's a waste of time.
Yeah, totally. But what I would like covered is where this bendy space-time citation is within the Cavendish paper.
It's in their imagination, heretic.
You're right. That is where it is.
Oh, my goodness.
That's why you can't link it in live stream voice text, because it's just in his head.
Well, I was trying to find the original paper, but there's a Harvard article about it, and I'm trying to find the original paper, but
it's just a leading question anyway. Do you really think that you're going to look in the Cavendish paper and find a citation of something that wasn't even conceptualized when that paper was written?
It's not about the conceptualized. It's a demonstration of a phenomenon.
Okay, a phenomenon being what? The bending of space-time?
The acceleration between two masses.
Oh, okay, but you said the bending of space-time, though.
It's inadvertently
Changing your claim.
Inadvertently the bending of space-time.
How do you know that?
Where's it at?
The attraction of mass is understood as the bending of space-time.
Really? And that's based on the Cavendish, what you just said?
Two masses. Well, gravity is the attraction of two masses, or the acceleration of two masses toward each other.
So what happens during Cavendish is due to the bending and warping of space-time?
Yeah.
Okay.
Whoa.
Can you cite that from Cavendish, then?
I can cite a paper, but Cavendish at the time, that's not what he was trying to prove. It was only proved later.
Who proved it?
I don't know.
Oh, okay. So why do you think?
I don't know. It was proven, but just by imaginary guy.
Well, saying I don't know, it doesn't mean it wasn't proven by an imaginary guy.
But it doesn't mean that it was proven either, because you can't cite it. You have no clue. You're just making a claim.
Well, there are citations by Harvard and...
Okay. So, a minute ago you had no clue. Now you say that you do have a clue. It's Harvard.
No, that's not a person. Harvard is not a person.
Okay, yeah, that's irrelevant. So just give us the source, right, that actually demonstrates that anything that happens in the Cavendish is due to the bending and warping of space-time. I want to see a demonstration, please.
I have a citation of Harvard, but I'm trying to find their sources, and I'm unable to find their link. It was probably not on the internet.
Yeah, it doesn't sound like it's what I'm asking for.
Is Harvard made up of people, or is Harvard just Harvard? Does Harvard?
Harvard's a college.
Is Harvard made up of people? Is a college made up of people?
Yeah.
Okay, so Harvard. You said Harvard's Harvard. No, it is somebody at Harvard who did it because Harvard consists of people, correct?
Yeah, but it's probably a group of people. It's not just one person.
Are we at probably now? I like probably.
So why is it so hard for you to provide a citation to back what you say? Is it because what you say is horseshit?
No, I have a citation from Harvard, but it's just going over the experiment. It doesn't.
Well, if you want to post it, we can take a look.
Yeah,
if you haven't posted already, we'd love to. We can all kind of go through it if you want to. It's no problem.
I mean, I'm a flurf, and I passed 6th grade, flunked 7th, but I can still read a little bit. Go ahead.
And we appreciate you. We appreciate you. Hopping on the mic, Soy Boy, as well. So I know the grills are hot, but
the grills are hot.
It is appreciated. So
that's good. That's a good. The grills are hot.
It just goes over the math and just what the experiment is, the setup and all that.
That would be a conceptualization of what's going on, then, not a physical demonstration. Math on paper alone is just a conceptualization. No, it doesn't. Demonstration would be physical, right? That would be in the physical world. So you physically manipulate the space-time that you're saying was bent, right? And then you would do that to demonstrate that it was the cause of the observed effect.
I mean, well, you don't really need all fancy math to see that it is moving two objects. So there's two objects moving.
Yeah, there's that part, but we want to know that the cause of it is the bending of space-time, like you said.
Yeah, well, it is the bending of space-time, because how else would these two masses be attracted to each other?
That's not how you present evidence, though. I'm sorry, but you can't just say well, it is. Just how else? Why? How isn't it? That's not really a good way to present to make a case.
Yeah, how is that
from
valid?
A third-party position.
You say what we're observing there is due to the bending of space-time. How is that validated?
What else would it be? It's that's not really an argument. Sorry.
Well, on this experiment, we can see that there's two objects accelerating toward each other.
Yeah, we see that part, but what we don't see is the bending of space-time part, which you claim was responsible for that effect.
We can see these two objects are attracted to each other, and
I know.
There's no other force exerted on them.
Listen, you are talking about an effect, an observed phenomenon. You're making a claim about the cause. It's that cause part that we're asking you to demonstrate. Then you just keep repeating what we saw. We know what we saw. We want you to demonstrate the cause, to validate the cause claim that you have for what we saw. Do you get it?
But is it not apparent?
No.
Here he goes again. He's just going to talk about the effect. Again, it's your cause claim that you're trying to demonstrate.
Well, it demonstrates that there's an attraction between forces, which is gravity.
Okay, and you got a cause claim about that. You say gravity is the bending of space-time, right? So how are you going to validate that it's the bending of space-time that causes any acceleration?
Well, gravity is also the acceleration of two masses toward each other.
Okay, so now you just changed the definition of gravity.
No, they're the same thing.
No, because I asked you what gravity is. You said bending of space-time, and I say it's two masses accelerating towards each other. Those are different things.
The bending of space-time is directly related to the attraction between masses.
And how are you going to validate that?
It just is. That's a common consensus.
From my research,
that's pseudoscience.
Well, I don't have all my sources directly on me. I can Google them for you if you want.
Well, it's okay. You can take your time, but it's from my research that they're different theories. They're not additions to each other. They're not bound the backs of each other.
How are they additions?
They're not additions, is what I'm saying.
Can you prove that?
Because Newton's was superseded and replaced with space-time. It wasn't like a backpack theory.
Well, Einstein's extended onto Newton's theory, though.
What I'm saying is it's not that. From my research.
Oh, you can believe that.
They're mutually exclusive.
Well, we can get into it. It's not like this isn't a belief thing, so we can go through it if you want to. But from what I've learned, Newton's gravity is like a 3 space, and space-time is a 4 space. So it's not the same thing. They're different from what I've learned. So you're like intertwining them. You're like, well, Cavendish is space-time and mass attracting mass. From what I learned,
how is the bending and warping of space-time an addition to mass attracting mass. It's a totally different concept.
If it's an addition, then you still have a fundamental flaw with your claim, right? You know that Newton was superseded because it didn't match certain expectations, like the presumed orbit of Mercury around the sun, different things like that. There's a three-body problem. You're going to have all of those if you're just elaborating on this fundamentally flawed claim of Newtonian gravity.
Soy boy, do you know what the bending and warping of space-time curvature is?
I have an idea of it.
Can you enlighten us, please?
Well, why would I need to enlighten you? It's just
you have an idea.
it's not. You can't see it. It's an invisible thing. It's just physics. Just physics.
If it's invisible and you can't see it, how do you know it exists?
Did you just say it's just physics?
There's like
I
I'm
can
not a
make any
physicist.
numbers equal anything I want if I really tried hard enough or made any number of formulas. That's the issue with math. Math doesn't
There is-
prove
So it's a
our reality.
concept.
There are proofs of this. I'm not a physicist, and I don't know the proofs right now, but there are proofs of it.
So
It
you
takes
believe
you back.
something before you've seen the proof of it.
I've seen the proof of it. I just don't have the proof on me
Okay, if you've seen it, then why don't you know what it is?
because I saw the proof of it, and I'm like, that's
Okay,
the proof of it.
Which was?
That space and space-time, like the curvature of space-time, is directly related to gravity.
Okay, that's the claim. Where's the proof?
I'm saying I don't have the proof on me. I can look for it right now, but I do not have it on me.
Okay, so
Oh,
you
that
don't have
sounds
the
like you're talking
proof,
to an
but you
officer.
already believe it. You already believe the claim, but you don't have the proof for it.
It's not my weed, officer. It's like, well, we found it on you, so.
I'm sorry.
Already
This
believe-
doesn't make sense. This is ridiculous.
It is ridiculous.
Well, but can we just acknowledge that the attraction of two that experiment is the attraction of two masses? Like, we can see that there is.
Sounds like a parlor
What do
trick.
you mean no?
Because
can
you're
see
making
it.
another cause claim. I don't know that those masses are attracting. There's just something happening, right? And
Well,
you're making
it's-
a cause claim as to why that's happening. What we keep asking you for is validation of that cause claim, and then you just loop yourself around and around and just keep repeating your cause claim.
It's also a man-made contraption. It's not a natural phenomenon occurring in nature.
The contraption is not what we're looking at. We're looking at the phenomenon that it is of those two objects being attracted.
Yeah, it's your cause claim we want validation for. We see the phenomenon. Now you tell us why it's happening, and we're asking you to prove that part, the cause claim.
Yeah. So, well, can you at least admit that there are two objects being attracted towards each other?
They move towards each other and then away from each other, then towards each other and away from each other.
So, can we assume that it's mass accelerating towards mass?
No, we're not going to assume anything.
Yeah.
So you're
It's not assumption. We
invoking
can see it.
Newtonian. So you're invoking Newtonian.
We're
gravity now.
not seeing the claim. You're seeing what you see. You're not seeing what you're claiming.
And the phenomena is two masses being attracted to each other.
How do you know that they're being attracted to each other? It's not just something else going on.
Because they're free hanging, they're hanging in space, and when these masses are near each other, they are attracted towards each other.
But when you say attracted towards one another, are you talking about a Newtonian attraction, mass attracting mass?
Yeah.
So that precludes the bending of space-time then. That's a different claim, different geometry.
Einstein
not
was
the
just
same
an
thing.
extension of the
No,
Newtonian.
okay,
Show
That's
that
in
then. Give us a
contention.
citation that shows that Newton's formulas collapse into Einstein's and vice versa.
Yeah, just so everyone's aware, that is in contention at the moment. So,
Soy boy, is it possible, just possible, I want you to look inside, that you're just making this stuff up?
No.
Okay, thank you.
How would I make up the Cavendish? It's cited. It's a thing. I'm not making that up.
You know what's interesting about Cavendish? Cavendish set out to prove density of the Earth. He didn't go out to prove mass attracts mass and two balls going toward each other. He didn't even go there. So you people, the globe side has one thing in the last 200 years, over 200 years, that proves your mass attracts mass. They have nothing else, so they go back to 1810 or whenever Cavendish happened to get your little mass attracts mass. Now, why is that, Soy Boy?
I just cited one thing. That was just one experiment. It's not the only thing.
Okay, what's the other thing?
Well, we are.
I'm
We're kinda
sure
going
there's
through-
numerous other things. I just cited
real quick.
one, and for you to say that's the only thing is kind of ludicrous. I mean,
Well,
that's
we
just assuming.
We're
But you
just
can't tell
we
me
just
what the other
rebutted how
thing
it's
is.
not an experiment. So
You haven't
What
provided
do you mean?
anything.
How do I?
You haven't provided one thing. You haven't provided anything.
I read a citation for the Cavendish experiment.
No, you didn't.
Yes, I did. The Harvard.
that wasn't a citation. Oh well. Did you actually post
How-
that?
Yeah, I did. I'll
Okay.
post it again if you want.
You posted a link. That's not a citation. I already told you what a citation is.
Yeah.
You need a quote from the link that you're posting, right? Specifically about the thing that you're claiming.
So so a citation can't be a paper about the Cavendish experiment.
No,
No, the citation.
Yeah, go ahead. See,
No, I'm sorry. I'm kind of stepping on you. Go ahead.
I think you're going to say the same thing anyway.
Yeah,
It's all
yeah.
good.
The citation is what's in the paper that's backing up what you're saying here. The source to the Harvard. That would be your source, right? And there would be other sources inside of that reference. Actually, that's your
okay, I see,
reference.
I see.
There's sources inside of that. So
Oh.
the citation's inside of there.
I'm going to have to get this man a citation for what citation means.
It's all good though. I mean, it's been a good conversation so far.
I mean, but like what the underlying part of the experiment though is the attraction of these two masses. Like,
Not
is
an
it
experiment.
indicative of gravity?
Yeah, I would say that is in contention as well. We're challenging that it's not an experiment because there's a couple issues with it.
But saying it's not an experiment doesn't. I mean that oversees or goes over the whole phenomenon that we see.
But
I mean,
we
that's
don't
just
see a
glossing over
natural
the whole phenomenon.
It's a man-made contraption. So,
But I mean, it doesn't matter if it's man-made. We're observing something that's a phenomenon. How does it being man-made affect the results?
well, because it's supposed to be a naturally occurring phenomenon. As far as I'm aware, if you want to be claiming that you're doing an experiment, first you need a naturally occurring phenomenon. You have to set up a valid hypothesis.
So if I took a box,
manipulate. This seems to be a mechanical contraption, which is sold as it's a parlor trick. It's sold as an experiment. This is kind of what I'm getting at from what I've learned. So it's selling you an idea, masked behind the idea that it's an experiment, but it's just a parlor trick. And
if
it
you don't
doesn't actually adhere to the scientific method. So it's not my idea, or I don't like it. It just doesn't seem to adhere to the scientific method, making it not an experiment.
If you don't like the word experiment, what would you like to call it? Because I'll refer to that because you don't really like the word experiment.
Well, again, I just explained it's not about my preferences. It's about adhesion to the scientific method. So if it's not adhering to the scientific method and it's claimed to be an experiment, then it's pseudoscience based, just period. So,
okay. I'll just call it the Cavendish phenomena because we don't really need a scientific method to see how there's attraction between masses. I mean, it's apparent that these masses are attracted to each other.
Soy boy, do you see? Here's a good one for you. Do you see mass attracts mass as Cavendish supposedly gives us in your fairy tale? Did you see mass attracts mass anywhere in the everyday world?
Yeah.
Where?
The Earth holding us to the ground. The Earth holding in the atmosphere.
Prove gravity. What is one instrument that proves gravity?
The Cavendish, whole Cavendish thing. What do you mean, no?
What in Cavendish fell down?
There's nothing falling. It doesn't have to be falling.
It doesn't have to be fall. You said Cavendish proved gravity, things falling to the ground, and then you said it didn't. So which is it?
I said that Cavendish proves gravity. I did not add the falling down part. That was you.
Oh, no. You said things fall down. You didn't say things fall over. Where is Cavendish? Where is mass attracting mass? Things going left to right, attracting one another, seen in everyday life. Where is it?
It doesn't have to be in everyday life. I already said the atmosphere and the.
Why not?
Because the Earth is a representation of gravity.
Okay.
I'm so sorry.
Can I
When you
ask
say that
something?
it doesn't have to have a representation of real life, you do know that we're talking about science, the physical and natural world. So we are most definitely talking about reality, mate. It has to be real.
It is. I mean, in everyday life, the forces are so small that you can't really see. I mean, the orbits, I guess you could see as an example, orbits, or the ISS orbiting around the Earth. That's an example of gravity.
Okay, but which is that an example of? Because it's not the mass attracting mass that you're supposing Cavendish. That's not mass attracting mass, the reason why things orbit. That's Einstein, general warping of space-time. Wrong gravity.
But you need gravity for there to be an orbit.
Yeah, but you're talking about Cavendish mass attracting mass. That's not the gravity that is, sky gravity. Sky gravity, balls in space, bending and warping the fabric of space-time. That's not mass attracting mass, sunshine, is it? You're talking about Cavendish.
It is. Mass attracting mass is also the warp of space-time, but
No.
It's not. We covered that.
Mass attracting mass is a mass. Hold on. A mass attracting another mass, right? Because of the size of that mass. Einstein, general relativity, the mass is in the fabric of space-time and bending and warping it. You can't choose one gravity, mass attracting mass, and then point to the sky when the heliocentric model turn around to you and say, no, that's Einstein gravity. You also have to understand that Cavendish wasn't a scientific experiment. I've already moved on to the second one. They moved on to something else because this one that you're touting, they couldn't scientifically prove this magic at a distance that Newton didn't want to be associated with. That's why it was superseded over 108 years ago. So don't die on this hill. This isn't the gravity you're talking about or we're looking for.
Well, why would it not be? I mean, it demonstrates mass attracting mass.
Hold on. It doesn't. Scientifically, according to the scientific method, it falls apart on all four things. One, it doesn't have an actual
a scientific experiment.
It is claimed to be.
This clown is fence hopping though, because initially his claim was gravity is the. Sorry, Jedi. Sorry, my bad.
No, you're fine. Finish your point, buddy.
Yeah, his claim initially was that gravity is the bending and warping of space-time, and he just keeps flip-flopping from that back to its mass attracting mass. He doesn't understand the mutual exclusivity between these claims, and he doesn't even know what he's claiming.
I'm claiming mass attracts mass. I know my claim.
That's not what you said.
I have said that before, so.
You said the bending and warping of space-time. That's what you said.
Either way, sorry, dude. Either way, can you give me the independent variable that Jim was asking you for the Cavendish experiment, please? What is it?
Independent variable is the mass.
No, independent variable. Something. Oh God. Okay,
you can change the mass. The masses change, and then it affects the acceleration.
Can I ask a question?
The dependent variable.
Sure.
What's the dependent
Hold on,
variable?
let Jedi cook.
Hold on, yeah, let Jedi go.
Can I ask a question? I haven't been in here in a while.
Hold on, let Jedi cook for a second. Hold on.
All right, let's go.
What's the dependent variable?
The dependent variable?
Yeah.
It's one of those two masses, so one of the masses.
Okay. So what's the hypothesis? Now you've given me independent and dependent variable, both which consist of mass. What's your hypothesis?
That mass attracts mass?
Yes, that's a problem. You can't have your cause and your effect as exactly the same thing. This is why Cavendish falls apart within the scientific method. The independent variable is mass. The cause of it is mass. If mass, then mass attracts mass. That's not a hypothesis, mate. You can't have your cause and
what you're
effect as the
doing
same
is
thing.
what you're doing is you're putting this in a scientific experiment when I've never claimed it
claims to be
a scientific experiment. I've asked you if you'd like to call it something else, and you guys refuse. So I'm demonstrating the.
We'll call it a parlor trick, and it is proof of nothing. How about that?
So
it's not scientific proof. Hold on. It's not scientific proof of anything now, is it? We can throw that away. So not scientific proof. It's just within your parlor trick, you assert something is happening and only can be caused on what you suppose it is. You've got no verification for this. You haven't varied and manipulated your presumed cause, which is gravity, by the way. This is why Cavendish experiment, you don't want to call it an experiment. It's not a fucking experiment and not proof of anything, Sunstring. Most definitely not scientific proof. So that's why they went on to the bending and warping of space-time. Have you got the independent variable for that?
Can you agree that experiment and a scientific experiment are different? Like an experiment they can be different. I can have an experiment. I can do something without a hypothesis, just see what happens. But a scientific experiment has to follow the guidelines of the scientific method. I'm just calling this an experiment. I'm not trying to say this is a scientific experiment. I'm just saying this is an experiment.
Go get a cite for that, please.
And we can assume.
Please go cite that, please.
Scientific experiment. What kind of an experiment is it?
A scientific experiment follows the scientific method.
That's what an experiment is.
You're talking about observational issues then.
It's redundant.
So you'll
it's like saying flashing lightning.
Yeah.
It is the same thing.
So you're saying you cannot have an experiment that does not. So you cannot call something an experiment if it's not following a scientific
Words
method.
mean things.
Great.
Words have meaning.
I've got a word for that. Yeah, that'll be pseudoscience. If it is said to be science but doesn't follow the scientific method, my friend, that's pseudoscience, fake science, not real, isn't it?
I've never said that it was science.
It is claimed to be science.
Hold on. Yeah, if it is claimed to be science and does not follow the scientific method, that's pseudoscience then, isn't it? By definition, correct?
In that definition, it would be.
We're not waiting around for you to say it. It's already claimed to be science.
Yeah, I never claimed it would. I
know, but we're not waiting for you to do that. It's already claimed to be science.
All I'm saying is this experiment shows.
No. Why should we accept your pseudoscience? Why should we accept your pseudoscience? It's not science,
I'm not claiming it's a scientific.
You don't have to. It already is claimed to be science.
Oh, where? Where is it claimed as a science?
Cavendish experiment. Dude.
Yeah.
All I'm saying.
If it was an experiment, they would not label it as an experiment. By doing such, they are negating everything they have done. But you yourself changing the name of it to something else doesn't change what they still call it. By them calling it the Cavendish experiment, they are presenting that is science, which it is not.
Okay, but this is going way over the underlying fact of these are masses attracting masses.
No, it's a
These have nothing to do with the scientific method.
None of that information even matters then. If you've proven the fact that it is not an experiment, none of the information in that is relevant or even matters because none of it can be held to truth.
So this phenomenon has no value whatsoever.
Because you have no science to back
Yes, for the simple fact of prove it.
Why should to?
Huh?
Why should to?
Well, I'm sorry, I don't understand.
If it's not scientific experiment, why should to be something to look into?
Because it's a phenomenon. If I see this phenomenon,
it's not phenomenon. It's not scientific proven. What are you saying?
How is it not phenomenon? It's a naturally occurring phenomenon.
Shit. No, it's not. It's not occurring in nature.
It is.
This is a man-made contraption.
It's
a torsion bar.
This doesn't matter if
it does. It's explicit to the whole argument.
Can I explain?
Listen. No. See, this is the problem with the Cavendish experiment. Your phenomena appears only in the experiment. It doesn't happen in the physical and natural world, my friend.
It does.
I'll ask you this: where?
Why would you not just test it in nature then?
In name of
What do you mean everywhere?
It exists everywhere, but we can only see it with the help of a man-made apparatus.
That's crazy, bro.
This is a problem, right? What are your control variables in the Cavendish experiment?
Kind of like
the masses.
No, that's your independent and dependent variable. Hold on.
Yep.
That's your independent and dependent variable. All of a sudden, when you fucked up the hypothesis, you can't have your cause and effect as the same thing. But my question's about your control variables, the things you keep the same. What are they?
Why do you keep jumping down to the scientific method? I'm not talking about the scientific method. I'm talking about the phenomenon.
Yeah, phenomena. Something happening within the experiment. You declare that it's happening elsewhere. Where?
If you walk on Earth, how do you stay upright?
Right, not working on his presupposition, because that's not in the Cavendish experiment.
Wait. You're just completely jumping the gun. You're not even talking about it. I gave you an example, and then you're saying, no.
Yeah, because that's not in the Cavendish experiment, is it? So
But
this is the thing. This is
why
this is why the Cavendish is not an experiment. Follow the scientific method, and is pseudoscience, not real science. Why are you believing in not real science? You naturally observe phenomena. Dude, why are you interrupting? I'm trying to help you. Your independent variable. That's fine. Your dependent variable, your presumed cause, is something that must be happening in the physical and natural world, because you want to answer the question: what causes that phenomena in the physical and natural world? So when I ask you what is happening in the world, your naturally observed phenomena, you ask me why you're not flying off the floor. I'm asking you for the phenomena. What is it?
Mass attracting mass.
No. What's the phenomena in the physical and natural world? Don't make me ask you to define mass.
I just gave you. It's the mass attracting mass. The acceleration of mass toward each other.
Where?
Everywhere. We just can't. It's so imperceivable. It's so small that we can't perceive it.
No problem. I've got gas that disperses in all directions and isn't attracting. That's mass that isn't attracting and is dispersing away. So where is your mass attracting mass? If gas is mass, the Earth. Right. What's the phenomena on the Earth? Why are you not following this? It's becoming frustrating. What's the phenomena thing happening on the Earth? Where's the phenomena thing happening on the Earth?
When you have a mass attracting mass, you have to have the masses. If you have a great mass, and the smaller mass will be attracted more to it. And our masses of our scale is so small that the forces is imperceivable, and with the help of the apparatus in the Cavendish experiment, we can see it. If there was some other very, very big mass, like let's say planets, orbiting each other, we'd be able to see it much clearer. But because of the masses on Earth are so small, the forces are very, very small. So we need the apparatus to see it.
So you should have just said something. You should have just said something falling. I pick something up and it falls down. Right.
I said that. I said, how are we standing upright? That's what I said.
Yeah.
I would challenge that.
You didn't say what I said. Yeah. But when you pick something up and you drop it down, right, that would be the question that you're trying to answer, wouldn't it? But we don't have this vertical movement in the Cavendish experiment. It's horizontal. And horizontal attraction isn't something that we see in the physical and natural world. And this is why I asked you about your control variables, because you have to keep everything.
The reason why it's horizontal movement in the Cavendish experiment is because it's trying to negate the gravity of the Earth. Because if it were vertical movement, then it would be affected by the gravity of the Earth. So when it's on the string, still in space, it does that so that the effect of gravity of the Earth is not affecting it. So by it moving left to right, that's the only way we can see the forces, because it would be diminished if it was vertical forces. So the forces of gravity go each which way. It doesn't have a direct up-down. And when you say up-down...
Putting it on a string doesn't negate gravity. All you're doing is giving a limitation to what it can move. So that alone also does not help in the Cavendish quantum code experiment at all. That's hypercritical to its own point.
It does, because if there was a force going down and we were measuring vertical force, if it was flipped, then it would be interfered by gravities, or the Earth's gravity, I should say.
That's awesome. Is gas mass?
What? I didn't hear that first part.
Is gas mass?
Oh, yes. Yeah, gas is mass. Every atom has mass.
Awesome stuff. So you'll understand the behavior of gas, right? Gas disperses freely and randomly in all directions and doesn't coalesce because there's lots of it. So there's a mass that isn't attracting itself. You've got a huge problem with mass attracting mass, because if mass is gas, then gas should attract gas, which it doesn't.
It does,
this is the thing. But it doesn't, because you have to understand that gravity in your eyes idea is just a vector downwards, even though you're going to post this horizontal fucking attraction that doesn't appear in the physical natural world.
Why?
Your gravitational attraction is just downwards. But you've got a problem when you come to gas. Why are you interrupting? You've got a problem when you come to gas, which is mass, because that's omnidirectional movement, which kind of fucks up your whole gravitational idea of mass attracting mass.
So why do you care if the Cavendish experiment has horizontal movement?
Because it's not, one, a naturally observed phenomena. Two, you can't have mass as both your independent and dependent variable. How you don't get this, I don't know.
Why does it matter
if
it's... Why does this naturally occurring phenomenon, the Cavendish, why are you saying it's not observed in the natural world, so therefore it can't exist?
Because it's not. There is no horizontal.
What? What?
The Cavendish experiment is horizontal attraction of mass. Show that in nature.
But it's attraction of mass. It doesn't have to be horizontal.
The whole point of the experiment was it was on a horizontal plane. So show us a horizontal. Show it.
The whole experiment shows it.
Just
but it's not an experiment because there's no.
Hold on.
Oh wait, there's too many people talking.
You're just declaring. You are just declaring that the source of any movement is what you suppose it is, which is gravity, right? If it moves at all. Now, for example, if I've got 5 Cavendish experiments that are set up in exactly the same way, you would expect, if this experiment was to be true, that every single experiment would act in exactly the same way. This is a problem with Cavendish experiment, it's falsifiability, because I can have 5 Cavendish experiments and they'll all do something different. Some might not even move.
Can you prove this?
That's a problem, isn't it? Yeah. Go to any...
No. I asked you to prove
Cavendish experiment and you will find... Yeah, I am. By the source material of Cavendish experiments where every single result is wrong or different from each other, if anything happens at all. And then you're just going to assert that because something may or may not happen, the happening is only attributed to what you presume it to be, which is gravity.
If you're going to...
This is why I asked you what your controlled variable...
If you're going to claim that Cavendish experiment doesn't work or doesn't have... What?
If you are not aware of your experiment properly, you are...
Sorry, I didn't hear that last part, but if you're going to say that Cavendish experiment works or doesn't work in different parts of the world, then can you provide some citation? Because you're making a claim. I mean, you might need a source for that.
You'll need a citation showing it's even an experiment. You haven't given us a viable
in
ID.
different parts of the world.
Huh? I don't know if it's my internet or what.
Yeah, Jedi is on a little bit of a lag, I think. Slightly, Jedi. Maybe drop at, come back in. But we're hearing you just fine. It's just a little delay.
Yeah, you don't have an experiment, so what are you talking about?
It's a phenomenon.
Okay, it's a phenomenon. That's not a fucking experiment. A phenomenon is not an experiment. An experiment is a test as to the cause of an observed phenomenon.
Yeah, I mean, it's not scientific, but it is an experiment nonetheless.
Then it's not an experiment if it's not scientific. Great.
If it's not an experiment, none of the results or none of the information you gain from doing said whatever you want to effing call it is valid or can be used because you're not doing and using the scientific method.
Hence why it's a power trick.
Okay, can I say, so I think that mass attracts mass, so I'm going to set up the apparatus. So my hypothesis is that mass attracts mass. Then my variables
That's not
are...
a valid hypothesis.
Why not?
That's why it's not science. You just said it's not science. Now you're trying to set it up as science. So which is it, bro? You got to make up your mind.
Because you're saying it's not.
Yeah, it's not. And that's not a valid hypothesis whatsoever.
Why is that not a valid hypothesis?
Because you need an independent variable. You need a dependent variable. You need a control variable. So you don't have any of that. You just stated the claim as the hypothesis. That's not
the control. The controls would be the length of the string, the torsion bar length, the mass of the torsion bar, and the dependent variable would be the masses on the torsion bar, and then the independent variable would be the masses near the torsion bar. Is that good enough?
Not sure.
Because I'll tell you why. Because your independent and dependent variable must be the same, must be different. They can't be the same. Because you are trying to prove the cause of a phenomena. A phenomena is something happening and you want to prove the cause of it. within your hypothesis, you've got both cause and effect as the same thing. You can't
They're
say
mass,
your
but
hypothesis.
different. It's mass, but the masses are in different locations. One on the torsion bar, and then the other is.
That's not a valid independent or dependent variable.
I think you're misunderstanding what I'm saying. I'm saying
he heard you very clearly. That's why he rebutted you with the way he did. And I agree with Jedi here. It's not a misunderstanding.
Okay, then explain to me how you understand it.
Good. Well, the independent variable is supposed to be your cause. The dependent variable is supposed to be the effect. They can't both be the same thing. Mass.
They can be, but they're in different areas. It's not the same place. I'm not saying that the independent and dependent are the same thing. They're both mass, but they're in different locations doing different things.
Shit! Listen to the doublespeak. I'm not saying they're the same thing. They're both mass.
Are you even listening to what I'm saying? They are both the same thing. They're both the same mass.
You're not
One is on the torsion bar, moving towards the other, and one is stationary.
You can't use the mass, though. What they're saying is as your variable, because you have to change mass to something else in a different one of those variables for it to be
and the mass would change. That's one of the independent variables.
But you're still using mass. You have to use something else as your variable. You cannot keep reusing the same thing. Size of that mass is irrelevant. You cannot use mass itself as your variable. It is
quite relevant.
Well, also the independent variable is something you need to be varying and manipulating. So
the mass of it. The mass. If there's no mass there, then it would move.
I've got to ask you, what is mass?
It's the atomic weight.
Now, what is it?
Finally.
Atomic weight. Are you sure?
Yeah. Do you know?
Just the bending of space-time, the weight of something, how much mass it has.
What about the resistance to inertia? Is it also that too?
Resistance of inertia, that's what inertia is. Inertia is the resistance of momentum.
Mm-hmm. So is that also how mass is defined? It's resistance to movement, for example?
No, that's inertia. Inertia is a resistance to movement. So what are you trying to get at?
Okay, cool. So mass is atomic weight. So I'm trying to ask you
how many atoms? That's a very simple, you guys can wrap your head around it. If there's more atoms there, weighs more, right?
Think of density.
Weighs more.
Yeah.
Sorry. Weighs.
Exactly.
Or more massive. Weight and mass are the same thing.
No, it's not. This is
no.
Why not?
Do you know the difference between the atomic weight and the density of the element?
Yeah.
Okay, explain, please.
The atomic weight is how massive an atom is.
Sounds like a mole to me.
Not quite. Okay, you keep going.
Me? I just said it.
You explained one side, but the density is something totally different.
But the density, it doesn't matter if you can have a soda can that's one mass, and then plastic it's another mass. They can be the same mass, but how does the density tie into this? I'm talking about mass. I'm not talking about density. Hello?
No, it's fine. I just don't understand why we're talking about this pseudoscience experiment. Still, pseudoscience, and you're just going to keep
discussing
it as
it shows gravity.
Yeah, of course you can.
It doesn't.
I think
it does. How does it not?
Jenna, go ahead, Jenna, real quick. Just want to get your question. I know you've been waiting, so I want you to just go ahead.
Real quick, okay, so in the heliocentric model, the moon is a skyrock. Skyrock is mass. Earth is mass. Mass attracts mass. Moon has not crashed into Earth yet at all this time later. And that's all I was going to say.
It's in orbit. Why would it crash into Earth?
Mass attracts mass.
Because it's mass, bro.
Okay. Do you guys understand how an orbit works?
Mass, okay? If mass attracts mass in your heliocentric pseudoscience model, and the moon is a frickin' skyrock, then it should have frickin' crashed into Earth upon its dawning, right? Upon its creation, whatever. Mass attracts mass. It's ludicrous. It's ridiculous. It's idiocracy.
That is,
It's okay,
okay, that is well, that has got my mind stumped because that is the most idiotic thing I've heard all day.
I don't know.
Well,
If you
that's
listen to
interesting
yourself, if you do a
because
replay, that'll probably be the dumbest thing.
Seems pretty logical to me.
So
as soon as Jenna mentioned the moon, we swapped gravities. That's Einstein now.
So
right,
you were saying,
sorry, right?
Jenny.
Sorry. Correct. Now that we've gone to the moon, that's the bending and warping of space-time for its orbits, right?
Well, we haven't switched gravity. Gravity is the one coherent.
Yeah, we did as soon as we went to the vacuum of space, mate. As soon as we started talking about orbits and stuff, that's Einstein general relativity. You know, the ball Earth bending and warping the fabric of space-time, and the rock ball moon spinning around it. That's general relativity, that is. That's not mass attracting mass. You don't even know your own model.
So are you saying that an orbit is not mass attracting mass?
Yeah, well done. Einstein, general relativity over 108 years ago. You know, 1919, the observation of a solar eclipse. Do you remember this part of your religion? Do you know this?
His objective was not to prove mass attracting mass because it's already been proven. He was just trying to demonstrate why.
Dude, let Jedi go. You have no idea what you're talking about.
No, not scientific. Sorry, guys. Sorry. Not scientifically proven, right? Remember, we've gone through this. Cavendish was pseudoscience. That came out of your mouth. So it's not scientifically proven, then, is it? This is why it was superseded 108 years ago, because they couldn't scientifically prove it. And that's why they went on to Einstein's general relativity. So when you point at the moon, that's not mass attracting mass now, is it?
They needed the extension of Einstein to prove the experiment. They needed the extension.
Not an extension. It's
it is an
claim.
extension.
No, it's a new claim that superseded the previous claim.
Oh my God! How did it supersede
the previous claim? I'll get you a citation for that right now, and then you can counter that with one that shows that they're one and the same. 1 second.
They act in two completely different geometric spaces. One happens in 3D Euclidean geometry. The other one happens in 4D pseudo-Riemannian properties. So they're in different geometries, mate.
So can I ask you something? Do you guys know how an orbit works?
What?
Yeah, of course.
Because you guys obviously don't understand how an orbit works. Jenny,
I absolutely understand how an orbit works, my brother. But however, that's a whole pseudo-scientific hypothetical idea of a world that doesn't actually exist. That's the point we're getting.
It's also completely non sequitur.
You don't know how an orbit works because you can't even get your claim about what causes it straight. So you definitely don't know how it works.
That's the logical fallacy. I mean, you're saying you're wrong because you couldn't prove this other thing that's irrelevant.
You can't just say that's a logical fallacy. What fallacy would that be, sir?
I just said it's a fallacy. I don't need to tell you what kind of it is.
Yes, you do. Or it's completely invalid. You can't just say, "Oh, that's a logical fallacy."
I just said
what is the fallacy?
He's saying that I don't know what orbit is because I didn't say something about something that was completely irrelevant.
What would the fallacy be?
Your opinion is that fact was irrelevant.
I think I'm calling you out.
He couldn't even quote what I said. He couldn't even quote what I said, but he knows it's both a fallacy, one that he can't name, and that it's irrelevant. How do you know that if you don't even know what I said?
Come on, dude.
Didn't the Russian space researcher just state not too long ago that the Earth, the moon flies within Earth's atmosphere?
The exosphere? That's a debated subject.
I don't know, man. So we can debate their claims about the heliocentric model. We don't just randomly believe everything they say. We can question it now. Well done.
The exosphere is like there's like trace amounts of like the atmosphere in space, and some people say it's atmosphere and some people don't, so it's just kind of debated. So I mean, if you want to say that the moon is in Earth's atmosphere, technically I guess you could say that because there's trace amounts of the atmosphere that far out, but
there's astrophysicists. One experiment that made use of creating orbit. How did they replicate orbit?
What is this?
How did they replicate orbit?
Like who? Like what? Like on Earth?
Yeah. How did they do it?
Well, you can't really replicate orbit an Earth because it's.
So why do you
don't
believe
have,
it then?
Huh?
Why do you believe it then?
Because it's just not possible in our atmosphere and on our Earth.
Why?
He believes it because it's not possible.
In our circumstance, it's not possible. If we were in space, we could have two things orbiting each other, but we don't have anything of mass of that size. We don't have anything that massive that we could put into orbit because Earth is already in orbit and it would interfere with it. So, like, you can put two magnets. Like, if you throw two magnets at each other, they kind of orbit for a little bit and then they hit together. Like, that's kind of close, but we don't have that kind of mass and attraction.
Why did they weren't able to replicate it in vacuum?
Because our magnetic field is affecting it, so we can't have a good orbit.
You can shield it. You can shield everything from magnetic influences.
It's not magnetic. Gravity is not magnetic. No, it's not.
What it said.
What it said.
This is another problem with the Cavendish experiment because your control variables, you've just admitted to electromagnetic fields. What about the gravitational influence of the sun or the moon or anything else? See, this is another problem with the Cavendish experiment. You're just going to blindly assert that any motion, even if there isn't any, is only because of your presupposition of mass attracting mass. This is why it's not a scientific experiment. It falls apart on every single step. But you still want to give us this pseudoscience as proof of your fucking bullshit. It's crazy to me. Why are you doing this?
Let's just keep it a little civil here. We don't need to interject swear words into here. But I'm preaching this.
Mate, you got a backbone, haven't you, mate? Be challenged on what you say. Don't focus on the words that I'm necessarily saying, and don't get hurt by my timbre.
I'm not hurt.
You on good, then don't bring it up again then. So I'm just challenging you on what you say because what you say is ridiculous. You're giving us pseudoscience and declaring it proves something. Do you understand how ridiculous that sounds? It's pseudoscience, but it proves something.
I mean, everyone's entitled to their own opinion. If you want to believe it's pseudoscience, it is
pseudoscience
by definition. By definition, it is pseudoscience. You believe in pseudoscience. I'm pointing the fact out that you're trying to sell us pseudoscience. How do you feel about both believing in pseudoscience and trying to sell it to other people? Do you not feel ashamed?
It's not pseudoscience.
It is by definition. Excuse me, 2 seconds. Hold on. We admitted to this 5 minutes ago, no less. If it doesn't follow the scientific method and is declared to be science, it is therefore pseudoscience. By definition, you admitted to this. You understand that the Cavendish experiment is not a scientific experiment that follows the scientific method, therefore is pseudoscience by definition. You are believing in pseudoscience and trying to sell people pseudoscience. I'm going to ask you again, how do you not feel ashamed of yourself?
Can I ask you one thing? Who said it was science? I mean, I'm not talking about the science here. I'm talking about the phenomenon. So is Harvard declared this science, or
we're back to square one?
Why is it called the
Cavendish? Because in order for it to be pseudoscience, someone has to claim it's science, as you said.
Yeah.
Who's done that?
It's called the Cavendish experiment. The word experiment. Sorry, the word experiment in science means hypothesis test. You make a supposition into a cause and effect relationship, and you test that in an experiment. When they say experiment, science, but when you look into it, there is no hypothesis testable, right? It falls apart on all 4 steps. It is not science, so therefore pseudoscience. They said experiment. Proof scientifically that mass attracts mass. So just feel ashamed.
I mean, for an experiment, like his hypothesis, like he was trying to prove density, right? As you said, like that was his hypothesis. So, I mean, there was a hypothesis to this information, to this experiment.
No, so it was not a hypothesis. Yeah, you say hypothesis. Hypothesis, so science then,
What?
Experiment, hypothesis, test, so science, right? You said hypothesis, so science, right? You said experiment, so science, right? You are, and they were, talking about a scientific experiment. It is herefore declared a pseudoscience because you know now, as well as I do know, that it doesn't follow the scientific method. There is a hypothesis that is malformed. You can't have your independent and dependent variable, your cause and effect as the same thing. How ridiculous does that sound? Stupid, right? To any rational thinking human being. So please understand that this isn't science, not proof of anything. You can't sell this to anyone. Stop trying.
So does it break down at the independent variable and the constants and the dependent variable?
What's the independent variable in the Cavendish experiment?
The mass. The mass near the torsion bar.
No, yeah, exactly. So you don't observe the phenomena in the physical and natural world. You create
it is in the physical natural world.
Hold on. You create the experiment and then you see it in there, but you don't see it in the physical and natural world. Otherwise, you would be able to give me the independent variable in the physical and natural world, because that's what science does. It deals with cause and effect relationships in the physical and natural world. Your independent variable must be a phenomena happening in the physical and natural world, not something happening in a man-made contraption. Idiot.
That's kind of contradictory. I mean, you're saying that it has to be a phenomenon that exists in the physical and natural world. So is our atmosphere and is our Earth not physical and natural?
Yeah, but the Cavendish experiment, a man-made device, isn't physical and natural. Now, is it?
So it does exist in the physical and natural world.
And that's where you observe your phenomena, in the man-made contraption, not the physical and natural world. Physical and natural world is outside of man's influence, as in we can't fucking touch it.
So do you want me to build this contraption out of vines and sticks and rocks? Would that be good enough?
I want you to at least have something falling.
What? It doesn't have to fall. Mass attracting mass doesn't have to fall.
Well, that would be the phenomena that we witness in the physical and natural world. You know, Newton and the apple falling from the tree.
Yeah, you guys don't believe in gravity. Like, you guys are talking about relative buoyancy, so buoyancy has nothing to do with this mass.
Give me a scientific experiment that proves it then. Being as we all know that the first one is pseudoscience, give me another one. Let's see if that's science too. It's not because we don't believe it. You've got no scientific validation for it.
I mean, if you really want to look in the Cavendish experiment, then you would see that it's not pseudoscience.
Have done. You've also just declared that it was pseudoscience 5 minutes ago because it doesn't follow the scientific method.
I've not declared it as pseudoscience.
Okay, then why are your independent and dependent? Why your independent and dependent variables exactly the same thing? That's a malformed hypothesis. Your naturally observed phenomena doesn't happen. Yeah, it is. You can't have your cause and effect as the same thing. You fucking idiot.
They are both masses, but those masses are located in different places. It's not the exact same thing. They're both mass, but they're not the same thing.
You can't have your independent and dependent variables the same thing, my friend.
They're not the same thing.
They are mass.
They're not. The one is on a torsion bar, and one is not. Those are not the same.
But they are both still mass, so it does not work. You need different variables.
But okay, so can you guys visualize anything? Is it possible for you guys to visualize in your head?
I don't know if you can.
I'll put up a link to a picture if you want.
Yeah, provide practical demonstration. We're not. Yeah,
so
we're not
saying
operating.
I have to use my imagination? You're saying I have to use my imagination and visualize something for it to be anywhere near possible. I don't know.
Because
that sounds like
doesn't seem like you have the capability.
Hold on, I was still talking. Thank you. I was still talking. But it sounds like you kind of have to be in like imagination land and like picture things that don't actually exist in the physical world for gravity to even be a thing. Anyway, next.
So the torsion bar mass and the mass that is not on the torsion bar, those are different. Do you understand that?
Look, mate, you just literally insulted us by saying, is it possible for us to hold an idea in our heads? I mean, you're fucking insulting, mate. Why anybody should talk to you from this point onwards, I don't know. That's insulting.
I mean, you guys are also a low insulting as well.
What? Because we challenge you on what you say.
Well,
Hey,
I mean,
man,
just
if
take
I
quantum
picture
eraser.
myself,
Is
if
quantum
I
eraser
just,
here? No, he's not.
if
So
I
within this
just picture
conversation, you're just being
myself,
a pussy.
Well, that's
yeah.
his
So if
thing.
I
So
just,
you just kind of
Yeah,
prove
if I
my
just
point.
picture myself
yeah, yeah,
finding
yeah.
gold
After you.
with a rainbow, right? So if
Jenna,
I
you're
just
really
picture
quiet,
myself
mate.
You keep
So if I
double
just
speaking.
picture myself, like just imagine it. Imagine I find gold at the end of the rainbow, right? Does that even like make it real? I can imagine any freaking thing I want, bro. But that's the whole thing. Is it doesn't make it true to observable reality. Okay. Observable reality, the sea is level and level doesn't freaking curve. These are really simple basics. Super simple basics, but you want to argue this bullcrap about gravity. Take gravity out of your vocabulary, and what are you left with, brother? You are left with relative density and relative buoyancy, which is actual, verifiable, provable physical science. It's not a pseudoscience like gravity. So if you take the word gravity out of your vocabulary completely, you have to deal with the physical science of buoyancy and density through various mediums. That's what the word relative means in relative buoyancy and relative density, relative to the medium that the object is in. Okay? Did I go over your head with that?
No, but have you ever seen the
Does
ISS?
that make sense? But
Yeah,
does
it makes
that
sense.
make
I mean,
Yes,
kind
we
of,
have.
but it's not really
So
correct.
if you take gravity, if you take the word gravity completely out of your lexicon, completely out of your vocabulary, you are literally left with relative density and relative buoyancy. Okay?
And
What the
mass attracting
buoyancy of
mass.
an object to its
Oh,
various
sorry,
medium, or the
Jenna.
density of an
Sorry,
object to its various
Jenna.
medium, right?
He's doing it
Sorry.
again. He's
I've really got
responding.
to point this out. Sorry, really got to point this out because we're trying to prove gravity here, aren't we? So it's interesting to me that gravity hasn't appeared as the independent variable, as the cause of anything yet. It's kind of interesting, right? We're trying to prove gravity, but it's not appearing in any hypothesis. It's not appearing in any experiment. We're just making declarations. If your presumed cause of a phenomena is gravity, then it better be a fucking independent variable and you better be able to vary and manipulate it. Oh, you can't. See, this is the thing.
The
You're
dependent
trying to prove
variable.
isn't gravity, is it?
That's a hypothesis is mass attracting mass.
Yeah, so your hypothesis should be a cause and effect supposition. If this presumed cause, then that effect phenomena. So if you are trying to prove the cause of a phenomena is gravity, you better have your independent variable as gravity, sunshine. Cause and
Mass
effect
attracting mass is the
relationship.
same thing.
No, it's not.
It is.
No, it's not. We're trying to prove gravity. We're trying to prove gravity. So gravity better be your independent variable, the thing that you vary and manipulate, so you can say that gravity is or is not the cause after you've tested it. That's science, right?
So is gravity
your presumed cause? Your presumed cause is what?
Mass attracting mass. Same thing as
so
gravity.
Not gravity then.
So why is it not?
Because you've got gravity, same thing as mass, as both your cause and effect now. If gravity, then gravity.
What do you think gravity is?
I don't think gravity is anything because there's no scientific experiment to prove it.
Oh, okay, I see here. So why don't we just call mass attracting mass if you don't believe in gravity?
But that would be gravity, wouldn't it? Or mass attracting mass. Two things magically attracting each other through distance, even though we decide to dismiss any and all other possible variables.
I mean, if you want to say it's magical, then...
Oh, it's not me. That'd be Newton. He didn't want to be associated.
When you say magically, that's also kind of insulting as well.
Well, that's what Newton said. He didn't want to be associated with the quote-unquote magic at a distance. Don't associate me with that stuff. It's stupid. He said, the guy.
Magic. You just said it was magically moving, though. What do you mean?
Yeah.
So you said don't associate me with that, but you said that.
What are you even talking
You said
about?
magically moving.
Yeah, well, that's what I said. It's because he said it. That's why I said it in the first place. The magic at a distance, he didn't want to be associated with it.
Okay, bro.
You haven't got science. You don't know what science is. How dare you come here with pseudoscience and say it's pseudoscience? Your formulation of a hypothesis as both your cause and effect is exactly the same thing. And I thought we were trying to prove gravity as the cause of the phenomena. So gravity should be the independent variable then to prove the effect. You don't know what science is.
I'm not a scientist, but I have an understanding of what science is.
Awesome. So you should have done it at, I don't know, grade 5, grade 7 at high school, right? Formulate a hypothesis, the supposition into a cause and effect relationship. Usually starts with a Bunsen burner and a beaker of water. If I had heat to the water, it will boil. Cause heat, effect boiling. Ding, ding, ding. Remember this? That's a hypothesis, mate. The supposition. Yeah, exactly. So that's how a hypothesis is formed. My presumed cause is the effect. Now, you notice that boiling water wasn't my independent variable and boiling water wasn't my fucking phenomena, right? They're different things. So you do know how to formulate a hypothesis, and with that understanding, you should know that the Cavendish experiment is pseudoscience. We all know that.
I just find it kind of funny how you guys aren't facing the mass attracting mass and like to beat around the bush saying this isn't this, so it can't be true. Instead of looking at the actual phenomenon, you just say this phenomenon can't exist because of blah 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 blah. Yeah, you were.
This is why I brought up 5 different experimental setups that have varying results, because it doesn't always move. Sometimes the oscillation, not attraction, mate, it fucking vibrates, you idiot. Sometimes the oscillation isn't near enough. Sometimes the oscillation actually pushes the balls apart. So this is why I asked you about your control variables. It's not just the fucking time of day, sunshine. That will be the magnetic influence within the room. That will be the heat within the room. That will be everything. But you would just declare that if there is some movement, that's got to be gravity, and then forget about all of the ones that
I didn't say that. I said the attraction between them is the attraction between them is mass attracting mass. If you see
when it doesn't move. What happens when it doesn't move? What happens when it repulses and goes the other way? What's that then?
I haven't seen that, so I don't know what that could be because I've not seen that.
You haven't seen the Cavendish then.
I have seen the Cavendish experiment.
No, you haven't, because that happened.
No, you ain't.
No, I ain't.
Go on ahead. This was in Cavendish's original fucking papers, you idiot. Cavendish's original papers. Couldn't get them to move. They moved a little bit. They didn't move, and they went the other way.
I've seen this experiment, and it does seem to attract towards each other, but then they hit, and then they slightly go backwards. So
that's brilliant. What happens when they don't move? What happens when they don't move?
Well, they do move. You have to have them close enough so that they do move.
Stream then restarts.
One day of the year, he put this stick up, and exactly 12, he measured, or some time or whatever. They measured this length, and then the same day, at the same time, he measured the same length, and he knew the distance between these places, and then he could calculate curvature on that. It wasn't that accurate, but he calculated. And I don't know who this was.
Do you know that was Aristophanes, and do you know why he calculated the radius of the Earth? Because he already presumed that the Earth was a ball anyway, and by finding out the lengths of shadows and inserting an R in his calculation, why are we all surprised he ended up with a ball, being as he presupposed one anyway? It's interesting, right? You've stood underneath a light, you know that the shadow is directly underneath your feet, but when you walk away from that light, your shadow increases. You've done that on the flat floor. So this isn't proof of anything, and most definitely not drop over distance. It was Aristophanes.
I don't think it was Aristophanes. This was some other guy after him. But I don't know that.
As the history guy here, it was Aristophanes who did it in ancient Greece.
Regardless, he assumed the Earth to be a ball, so he used the calculations to find out a ball. So guess what he got? He got a fucking ball. I've just walked you away from underneath a light. You understand walking down the street at night, when you walk away from one light and the shadow increases in front of you. He'd done this on a flat surface. So again, not proof of anything.
The scale, though, that wouldn't have. It would be minuscule. It wouldn't have any effect.
What do you mean scale? The sun's really high up in the sky and the Earth is fucking big. At one point, you stand directly underneath the sun. It was a well, by the way, and you saw the reflection of the sun's light directly ahead. 500 miles away in sighting, somebody else with a fucking stick noticed the shadow. Brilliant. The Earth's really big. The light's really high. You've moved away from underneath the light, and don't be surprised when the shadow increases in front of you. The surface of the Earth does not need to be curved for shadows to increase, you idiot.
So are you saying that the ISS, they didn't calculate it, so therefore they couldn't launch the ISS?
Well, they can't launch the ISS into second law of thermodynamics violation known as the vacuum of space because they declare it to be an open system. So you got fucking problems there. That's a defiance of entropy. You can't defy entropy, can you? It's a law of nature. Entropy increases. You're talking about. Go on, what?
So I have a question. What do you mean by a second violation of the second law of thermodynamics? What do you mean by that? Can you paraphrase?
Yeah, do you know what entropy is? Direction, right? I'll give you an example. I've got a hot cup of coffee and I leave it alone. What happens to the hot cup of coffee? It gets
cooler.
Cold, yeah, exactly. High pressure systems disperse into lower pressure environments. I've got a gas container. I pop it. The high pressure disperses into the lower pressure environment. I've got a vacuum chamber. I open the vacuum chamber. The higher pressure outside disperses into the vacuum bit, right?
So what causes that, though?
Now,
what causes that?
Don't know.
Vacuum.
Dude, we're talking about a law of nature. Right, you do understand that laws of nature. We've literally got down to the last bit of it, and entropy is a law. It is what it is. It does what it does.
So you're saying
high pressure. High pressure systems disperse into lower pressure environments. Is the Earth an open or a closed system?
It's open.
Awesome stuff. So you will understand that one, we are devoid of any necessary antecedent for the consequent of gas pressure. As in, to have gas pressure, you need a contained volume for the gas to exist in, and the pressure is defined as the force that the gas exerts upon the walls of the container. Problem one, we're breathing gas pressure within an open system. Fuck me. Problem two, it's an open system. So according to laws of nature, the high pressure environment should disperse into the lower pressure environment. We've got high pressure here, there's a vacuum out there. You understand what's going to happen. You burst a balloon before the gas is going to disperse or fuck off into the lower pressure environment.
So there's one problem with
your
that.
Satellite. Go on, say gravity. Say it.
No, there's a problem with that. You're talking about how if we take a vacuum chamber in an atmosphere and then we release it, the atmosphere fills that. So my question to you is, do vacuums suck?
No, the high pressure disperses into the lower pressure environment. You idiot. I've said this 3 times.
Yeah, right. And that's in an atmosphere, though.
Yeah, exactly. Everywhere. Dude, everywhere. It's a law of nature, isn't it? This is why it's a law of nature, right? So everywhere then.
So do vacuums exert force?
No. The high pressure system will disperse into the vacuum. It's the gas that's here that's busy and energetic, you know, the stuff that moves freely and randomly in all directions and only can be stopped when it bounces into something physical. Like when you contain it in a football. There you go, I've got a container of gas and I can kick it around a football pitch. If I burst the ball, the high pressure system within the ball is going to follow this law of nature and disperse into the lower pressure environment. So I'm going to have to say this again. We're breathing the consequent of gas pressure in an open system. Fuck me, there's problems there because the gas needs something to press upon. It's not going to press on a vacuum now, is it? I'll tell you what it is going to do. It's going to disperse, though, because the energy comes from the gas. The gas moves freely and randomly in all directions, and there's lots of space out there for the gas to freely move into because there's nothing physical in the way. So your International Space Station is in the second law of thermodynamics violation. My friend, you can't have vacuums of space uncontained from gas pressure systems, you idiot.
So in the heliocentric model, we have an atmosphere which is, in the heliocentric model, is described as like it's held together from the gravity, and that gravity creates the pressure that is around us, holding the air in. And in the heliocentric model, it is described that the vacuums, they do not suck. So, but can I finish?
Hold on. No,
Why?
Because no one here said gravity. No one here said vacuums suck. Right, and you have said gravity.
Okay, just
also,
interrupt
you
me
have
some
said
more.
gravity. Oh, excellent. You said gravity. You got a scientific experiment that proves that.
Can I finish what I was saying about the heliocentric model?
You said gravity. Yeah, have you got gravity and you've got a scientific experiment to prove that? You're going to say gravity is defeating entropy. You're going to say that gravity causes a decrease in entropy where entropy increases.
That's not what I was going to say.
Have you got a scientific? Awesome. I don't care. Which direction's gravity relative to you and the Earth? You pick something up and you drop it. Which way's gravity?
Relative to me, it's down.
Awesome stuff. And which direction does gas go?
It's held together, down.
No, no. Gas disperses freely and randomly in all directions.
But
no.
Then, if it was,
which way does dude? Which way's the gas going right now? Where's it going?
Which direction? I can't see.
Awesome, but you understand that it's described as moving freely and randomly in all directions, right? All.
That's on a small scale.
No, yeah, in all scales, natural laws, right? Here in the physical and natural world, every single scale, right? So you understand that a football takes the shape of a sphere because the gas is pressing in every direction outwards, right? Like a balloon, the gas is pressing 360 degrees omnidirectional around it, outwards in all directions. You say gravity is just a vector downwards because you pick up a rock and you drop it. Awesome stuff, that's fine. Scientifically speaking, though, when we're looking for an observed phenomena, I'll tell you what, even though you haven't given me gravity, I'll let you fucking have it. There you go, mate. You've scientifically proven it, whatever. But we've got a fucking problem now, because even though gravity is just a vector downwards, the gas is moving freely and randomly in all directions. So we don't have a phenomena to even start asking the question, what caused it?
Gas is moving freely everywhere, but that doesn't mean that it can't be influenced by gravity.
Well, it isn't, because I've just told you that scientifically we don't have the observation of gravity doing anything to it.
So you're saying
gas moves freely and randomly in all directions. Gravity is just a vector downwards. If I was to pop a balloon, the gas would move in all directions. If I was to drop a rock, the rock would go down, right? You don't have an observed phenomena.
That's because the rock is too massive.
You don't have an observed phenomena. You don't have one. Gas moves freely and randomly in all directions. I'll give you gravity.
I'll give you
gas, mate.
I'll give you an example. So the atmosphere has different layers of it. So the closest to the Earth is the densest, and as you go away, there's less dense. So that can be described as gravity having a bigger pull closer to it. So when the gas is closer to the Earth, it has a bigger pull, and there's more atmosphere. It's higher pressure.
Where's the gas produced?
The gas isn't produced. You can produce things like trees can produce, or exchange, I should say.
There you go. Nitrogen cycles, carbon cycles, yeah. So the gas is produced down here at ground level because of biological and chemical cycles, right?
So why would it not go up?
Oh, it does. This is the thing I'm trying to point it out. So within the mass of the Earth, the thing that you're saying is keeping the gas here, the first instance of the gas is to fuck off away from the mass that you say is attracting it. That's brilliant. So we don't have the observed phenomenon of your mass attracting gas because the first instance of gas is to move away from the mass. Obviously, gas moves freely and randomly in all directions, so you don't have the naturally observed phenomena of gravity acting upon it. It also doesn't appear in... No.
We see air or the atmosphere randomly moving every direction on a small scale, but if you were to look at it from the ISS perspective, that wouldn't be the case. You would see it would be denser, and then it wouldn't be dense. It's too far to see exactly, but you can see the levels of the atmosphere.
Yeah, I know, but you understand what happens when you burst a tire? The gas comes out. Because you can't have high pressure environments uncontained from much, much lower pressure environments, because that's a lot of space for the gas to freely expand into. Do you know what the inverse square is?
That's only because there's an atmosphere.
No, the atmosphere is the gas, mate. The gas that we're talking about, the stuff that we're breathing, the atmosphere, the gas. Yeah. That.
Yeah, and that's created from the gravity. The reason why we have pressure.
No.
What do you mean no?
No.
What do you mean
no? Because one, you haven't scientifically proven gravity, right? Two, you don't have a naturally observed phenomenon. Hold on. Two, you don't have a naturally observed phenomenon of gas going down like rocks and shit, because gas moves freely and randomly in all directions. Please don't go up into the International Space Station, turn around and take a picture of the Earth and declare that's what it is, because that thing, the International Space Station, is in a second law of thermodynamics violation. You're also talking about a decrease in entropy every single time you invoke gravity. Decrease in entropy, sunshine. What the very fuck are you talking about? You don't know these natural laws, do you? You don't know what science is, do you?
If gravity doesn't exist, how do you explain the rock falling or people standing upright?
We did that earlier. So that would be relative.
I didn't hear that.
That's fine. That's
You
fine.
just said it.
Shut up.
You said it.
Shut up. That'll be relative density. I'll give you an example. I've got a container, a fish bowl of water, and I've got an egg, and I drop the egg into the water, and the egg drops to the bottom of the water. Brilliant. I then add salt to the water, making the water denser, and guess what happens to the egg? It rises. Now, scientifically speaking, hold on. Scientifically speaking, being as I've varied and manipulated the medium in which the egg resides in, then the cause of the egg moving is the medium in which it is in. That's relative density, my friend.
What would happen if there's no gravity? Like, if you're in the ISS, have you ever seen those astronauts drink water?
The International Space Station is the thing that is in contention at the moment because of the place where it resides. The vacuum of space.
Have you ever seen anyone in a zero-G flight, like in an airplane going zero-G?
A parabolic flight where everybody's falling at the same rate?
Yep.
Yeah, an illusion, yeah.
Okay, so have you seen anyone have an object that stays up? It just floats, right?
This isn't proof of anything, mate. This is a non-sequitur.
What I'm getting at is that you can put a Alka-Seltzer tab. I've seen this in the ISS. They put an Alka-Seltzer tab in this water, and it's not going to the edge or anything. It's staying in the middle where it's the densest. Like, you need to have gravity. If there's density, you can have density, but you would need to have gravity in a uniform.
You need gravity because you're on a spinning ball. You need gravity because you've got people 180 degrees antipodal from you in Australia standing upside down. You need gravity to keep the waters of the earth attached even though they're tidal and not spinning off. Do that again. You're the one that needs gravity, my friend, so you better scientifically prove it. Don't ask me what gravity is on the fucking flat earth.
What?
Fucking pig.
What? I didn't even burp. That was some other guy.
That's fine, but you still haven't proven gravity, and you haven't negated the law of nature.
I've been trying to show you the mass attracting mass, but you guys just say that's not possible because some guy made this apparatus.
Is it a scientific experiment that follows the scientific method? It's pseudoscience, not proof of anything. That's what they moved on to the second idea.
It's not even about...
So not proof of anything.
It's not about if it's scientific. It just shows a phenomenon. Can we see the phenomenon that is the mass attracting mass, mass accelerating the mass? Can we see that?
No, because you haven't told me what the control... Because two things. One, you haven't given me the control variables, and two, you're just asserting this always happens. It doesn't always happen.
It does.
I've given you. It doesn't, and you don't. It doesn't, and you don't know. This is why you told me earlier you're going to go away and do 20 experiments. Do you remember that? You don't know. You don't know.
The thing about his logic, because forget about the rhetoric and the words. The same illogical form that he's using is the same when others say, "Who cares about a phenomenon?"
But like, I'm not talking. It doesn't.
Who cares that this condition that we've created has nothing to do with a natural phenomenon?
It matters because it's strictly correlated to gravity and the explanation of
other people would
our
correlate
Earth.
These made up phenomena to things as well, and doing the same thing as all.
I can correlate them if you want me to. Okay, then. So we can't even admit that this experiment shows. I'm using experiment because that's the only way I know how to say it. But even if it's not scientific, can we at least agree that there's mass attracting mass?
No, because you fail to recognize that when these experiments are done, there are three different things that happen. I'll state them again. One, the objects don't move. Two, they do move towards each other. And three, they repel. But you won't admit that.
So you're cherry picking some information out of here, and saying that these.
Not cherry picking. You're the one that's cherry picking. You're only saying that when it moves, it moves. I'm pointing out there's other things that you haven't taken into account. I'm not cherry picking. I'm giving you the whole basket of fucking fruit. I'm giving you this. Jesus, man, I'm fucking trying to help you, and I'm giving you more information that you don't know, and you just want to hand wave it away because of your fucking belief that you live on a ball. You want to die on this hill. Mate, I ain't trying to convince you of anything. I'm just trying to tell you, one, you're wrong, and you might want to fucking look into this. This being 3 different things happen within the Cavendish quote-unquote experiment. Doesn't move, moves one way, moves the other. You've not looked into it, but you did say that you would go away and do it. Go on, go away and do it. Tell me what you get.
All right. What about I can pull up a YouTube video if you want, showing the acceleration, if that's easier to see.
That's fine. That's fine. That's one video. Remember, that's cherry picking now.
There's a couple though.
Oh, awesome! So a few that show attraction. Brilliant. Do you want me to give you the original Cavendish papers?
Sure.
The original ones. Okay, cool. And you will notice within his framework, they didn't move. They moved the other way, and they moved together. Right.
All right. Let's see.
And then replicate experiment in liquid.
So even if there's one case where they do attract, how do you prove that is not gravity?
Oh, well, you haven't got gravity as your independent variable.
Oh, what was that?
It's called a burden of proof reversal.
What does that mean?
Where the burden of proof is reversed.
Okay, whatever.
What? It's fallacy, mate. I'm just telling you what it fucking is. You just said fallacy earlier and couldn't fucking name it. At least we know what they are individually and can express them to you.
I don't know every single fallacy.
Yeah, I know. But you would just say that's a fallacy, that is, without even understanding what the fucking word is that you used. Like experiment.
Is there a citation for the original paper, or?
Yeah, just go find the original paper. I'm actually not going to do your fucking
You said you were going to post it.
Yeah, I can't be asked now because you're a lazy cunt. It's a Wikipedia search.
Oh my
it's a Wikipedia search away. It's a Wikipedia search away. You're on a device right now, aren't you?
So
you're pressing buttons, aren't you?
You just said you were going to cite a paper that showed that it attracts, it doesn't attract, and then moves the other way. And then you say, I can't be bothered.
Yeah, I can't be bothered for you because you're a belligerent idiot. I have given you the opportunity to do it yourself. How about that?
But
wouldn't yourself.
But if I were to find my information, you would just say that's cherry picking. So I want something from you so that I'm not accused of cherry picking.
I told you where to go. Go and pick my cherry from my tree that I told you to go and get it from. That would be the original papers from Cavendish. You can find them on Wikipedia.
If it's so easy, then why don't you send them for me?
Because I can't be bothered.
So you're going to say, I can't cite anything.
Hold on. Do you not want to be in control of your own learning experience, or are you going to pass it off to fucking other people?
Thank you, Amish.
There you go.
So, is there any citation on? Is there any?
It's going to take you a while to read that.
So, is there any part of this specifically, so I don't have to read through all of it, that says that they move, that they don't move?
You should probably read through all of it, so you get a base understanding about what it is.
Well, you're giving me a source, not a citation.
But that's fine. I haven't given you anything somebody else has.
That's why he said, find it yourself.
I know, but he did. No, actually, he first said that he was going to give it to me, the original, and then he said, I can't be bothered.
He said, that's me. Jedi said, yeah. Jedi said, because I'm tired of this, mate. Right, this conversation's gone on for an hour, right? You haven't admitted to anything, even the claim that fucking Cavendish is pseudoscience, right?
Well, you haven't admitted that they don't move, so. If you're gonna claim that they don't move, then I'd assume some sort of source or something, but then you just say I can't be bothered.
There you go. There's more in the live stream for you. There you go. Everybody else is giving them to you now. You've got a plethora of information to look through, haven't you?
All right, let's look at this YouTube video.
Oh dear, well you were going to give me a YouTube video and that was sufficing for you, so why is it not sufficing the other way around?
I'm looking at it. I'm not saying this does not suffice. I'm watching it right now. I'm skipping all this. Huh?
Put yourself on mute for a bit. Watch the video.
Oh, which one? I mean, there's a couple of them. I should watch all of them?
Yeah, fuck off and watch them all.
All right.
Weird how he's asking for the citations from the paper that he brought to us to support something he said.
Yeah. Interesting, right?
It came in after
Yeah.
citing this experiment as if he had proof like he'd done it. And then when you
Whoever that,
find it,
you're really quiet, whoever that is, man. I could just about hear you.
Sorry.
Who was that? No, you don't apologise, mate. Just speak a little bit louder.
Yeah, wife and kids are in bed, so I can't go on a big rant like I want
Sounded
to.
like an incantation or something.
Your settings are jacked, I think. Whoever that is talking, we can just barely hear you.
Okay, so
You should give a strike to Scare Bear as well for that disrespect earlier.
What? Or was that him who burped into the microphone?
Yeah, he just unmuted just to do it too, which is fucked.
Yeah, I'll have a word with him later.
Accident. I've been here for a while. Chill out, Cal. Relax.
Wow, there's a live stream, dude. Like,
Don't toss a stone in a glass house like you've never actually done something on mic you didn't mean.
no, I push to talk, dude.
I thought he seemed pretty genuine from what I've heard of him so far, for what it's worth.
In what way do you mean genuine, mate?
There's a strict no burping
Care Bear?
policy.
Yeah, I don't find him to be a troll. I don't find him to be a narcissist or a toxic type, from what I can tell so far.
No, he truly believes in the shit. Like a wizard.
Scare Bear? Maybe I'm confused about who we're talking about.
Yeah, Scare Bear seems all right. But
I thought you were talking about the guy that we were just talking to.
Right. That's Soy Boy.
No, just kidding.
Oh dear.
Yeah, Soy Boy is definitely not genuine. I wasn't talking about him.
Hey, Rad, when Miggy has almost 800 followers.
Holy crap.
200,
CB,
let's go.
You got a TikTok account yet, CB?
Yeah, I made one just to follow.
Yeah. And just figured out how to increase them faster. Like, yeah,
200
insane.
to go. We gotta put some respect on Elijah's name. I've seen y'all been working together on this project, so good job, guys. 200 more to go, and we're live, baby.
What does live mean? Live for like 30-second clips that are live, or it streams just live all day, all night on TikTok?
Live stream, baby. Good. The Wild Wild West. Yeah.
You told me you weren't going to put that evil device crap on your evil device.
I haven't. I refuse. I just made an account on my phone, on my computer, and that's made a follow. I'm 1 out of 1,000. All right, you can count me. So if you guys haven't made an account to TikTok, go do it now and follow Miggy on TikTok. I think it's Mayhem 100. We need to get to 1,000 subscribers so we can go live. There seems to be like 0 people streaming Flat Earth on there. When I searched it, there was nobody. So we could totally dominate the space. So if you don't have an account, go make one now.
All right, so I've watched all the videos. So the red, like, Christmas tree ornament one, that one, it might show attraction, but it's also outside and it's jiggling in the wind, so I wouldn't really say that's not really any controlled environment. So that one doesn't work. Even if it's not repelling or if it's attracting, that one, just rule it out. The one with the 66 symbols, the guy doesn't even show the example of it. He doesn't even show it working and just goes over what it is. And the tilt washer Cavendish experiment and the Cavendish experiment in G and the Cavendish gravity experiment time-lapse version 1, those both show attraction towards it. I don't get where there's no attraction. They hit it, they bounce back, and then they are attracted towards it. I don't get where there wouldn't be any attraction. But all of them, except for the what is it? The red ball, like Christmas light one, and the 66 symbols don't even show real experiments. So there's no really evidence that they don't attract. They all, the valid ones that actually show the experiment, all attract. The red ball is swinging in the wind, and it's swinging in the wind from the start. You can see it. Like, that can't be valid. Even if it is attracting, it's not valid.
Yeah. I didn't post that, so I don't know about that one, buddy. Did you read the Cavendish paper?
Well, I watched videos because it was very easy to watch, and I didn't read the whole thing. But who is this? The admin cited these ones, so these are all showing that there's attraction. So I didn't see anywhere in here that there wasn't attraction, and they hit the more massive object, and then they bounce back, and then they accelerate towards each other. And he said the relevant part of this video, the first video, I don't really get what he's trying to say here.
You're asserting attraction. You're not observing or measuring attraction. You're just measuring movement. You're just measuring movement of some lead balls or whatever your instruments you're using, and then asserting the cause.
You can see what is happening.
You can see something moving. Yes, you can see something moving.
Hold on. Why'd you just lie, soy boy?
What did I lie? Oh.
So the first one with the physicist?
Yep.
It doesn't work at all. What are you talking about?
He was just going over it. He didn't even demonstrate it.
Did you listen to what he said? He said they couldn't get it to work, so the technician got mad and sawed it in half.
But I was talking about examples that are not attracting. He doesn't even show examples that are. He's just saying that it didn't work.
It doesn't work. That's the point.
He was saying
that's a university professor. The apparatus they're using is a scientific grade Cavendish experiment, Cavendish setup. Cost like $1,200, and it didn't work. That's the point.
Anyone can say anything. He could have said it didn't work, but it did work.
Why would he do that?
There's numerous reasons. Why would NASA lie? There's numerous reasons.
Okay, so he went to do a video on the Cavendish experiment. It didn't work, and then it did work, and he just lied and said it didn't.
Like I said, this is not. Wait. Can I finish? This. I was asking for any evidence of it not working, and he's saying it's not working, but that's just him saying stuff. Anyone can say anything.
Okay, and then this is next. Hold on. The next video, and they use washers, and then they get one. They get one rotation when the washers are oriented one way, and a different rotation speed when they're oriented another way. And the next one, these Christmas bulbs aren't heavy enough. They're not massive enough to do anything.
But there was a flopping in the wind, so.
Oh, now it's the wind, right? So you got lots of excuses.
Oh,
so then there's the last one, and then there's the last one that doesn't work, right?
It does. You can see it.
Dude, the last one, Cavendish Gravity Test Time Lapse version 1, it didn't work.
What part of it didn't work?
It did not rotate the predicted value. It didn't, dude, it did not rotate the predicted value. It even says it in, read the description.
It did not.
Due to environmental problems, air blowing across the apparatus, the results of this experiment are compromised.
It didn't rotate at the. When you have set values in math, they're not going to line up in reality. They aren't perfect.
Yeah, have a nice day.
That was funny.
Brilliant.
So the point is, right? So, okay, and then the first one I posted, they're telling you what it actually is. They're measuring an oscillation, right? What happens is it rotates, but then it starts bouncing back and forth. It oscillates. And they measure the rotational, the angular rotation, how long it takes to change the angle, right? And from that, they infer G. Okay? So That's how it's done. You didn't even know what the experiment was, and it's your evidence.
First of all, are you just going to deny that there's an attraction between these forces? We can clearly see in the
can say anything, right?
one.
Wait,
Let me
anything,
finish.
right?
No, you're cherry picking.
Come on,
you're
let me
cherry
finish.
picking. You're cherry picking.
No. Let me finish. You guys all about letting people finish, but you're not going to let me. What's up with that?
Because you're making baseless claims.
That's not valid. You're not going to interrupt someone because it's not valid or whatever. You hear them out. That's a civil conversation. Let's have a simple conversation. This is a debate live stream.
Yeah, I can hear you snickering. Okay. You're not
just
clever,
insult.
dude.
Are you just going to insult me? Like, is that your answer?
Saying you're snickering is an insult? How is that an insult?
It has negative connotations. But let's not get into that, though.
Insult. Yeah, you're not clever, dude. Okay.
So
what you're doing isn't working.
The time lapse, you can clearly see that the mass is attracting, even if it's not their expected value.
Oh, you can clearly see the masses are attracting. You can clearly see that.
They accelerate towards each other. Did you not see that? I mean, I thought you watched the video, right?
I did. Yes.
So, do you see them?
I didn't leak the conclusions about why we're making that observation.
But can you see that these masses are attracted?
Yeah.
So we can conclude that these masses attract mass.
Why is that? Why can we conclude that? Why can't we just say it's unbalanced? Or there's wind?
It's not. He shows at the start of the video that we can see at the start of the video that he demonstrates that without any mass around it, it oscillates a little bit. There's some oscillation, but when there's masses are placed, the oscillation is.
He said himself that it's inconclusive. He said it himself. It's in the description of the video.
But so we cannot see that there's mass attracting mass?
No, you cannot.
So there's no mass attracting mass?
No, there is not.
So the time lapse is completely invalid, and there's...
No, you're drawing a faulty conclusion from the observation.
How so?
Because it was unbalanced. So, if I take a string and I hang it between two weights, right, and it's not dead center, what happens? Does it rotate?
One side goes to the ground. Hello?
Closer than that, right? When they're close enough where they're not a slight imbalance, dude, not a huge imbalance. It will rotate, especially if there's tension on the wire.
But is there not acceleration, though? I mean, you can clearly see the acceleration.
How did you measure the acceleration?
I said you can see it. I never said you can.
You have to measure it. So acceleration is the rate of acceleration, right? What is an acceleration? Tell me.
So are you saying that you can't...
Tell me what an acceleration is.
Are you telling me that you cannot see a car accelerate? Are you telling me that you cannot see a car accelerate?
I can't see a car accelerate, but we're not talking about a car. We're talking.
Can you measure that just with your eyes?
No, you cannot.
Then it can't accelerate.
It's your claim.
Then it can't accelerate, right? That's based off your logic.
I'm asking you for the evidence it's accelerating.
You're telling me that I can't see it accelerate with my eyes, and I'm giving the same example of the car, and you're saying the same thing as me, that we can see it accelerate. So
I said you can't. Not from looking at it.
So you cannot see a car accelerate.
You can't see a car accelerate if it's an extreme acceleration, but that's not this case. You're trying to compare apples to oranges. See, this is a rotation, right? So you're saying it's accelerated. That means the rate of change of the rotation is speeding up.
Yeah, you can see the rate of change in the time lapse. It's the time lapse. Did you not watch the video?
So tell me the change in angle. Like, how much does the angular change increase? Quantify it for me.
You can see it increase.
Yeah, quantify it for me.
It gradually goes towards the balls, and then it picks up. And then once it hits the balls, it rebounds.
Yeah, quantify it for me.
You don't need to quantify a car accelerating. I can see the car accelerating. I don't need to quantify this.
Well, in science, we quantify things, right?
Yeah, I'd have to analyze it pixel by pixel. Huh?
We don't. Oh my God, dude.
So there's no mass attracting mass in this example?
No. And the guy that made it admits it. The only one that thinks this is an example of mass attracting mass is you. And nobody else.
Not in reality.
He's just saying due to the environmental problems. I mean, it's compromised. It's compromised, but it doesn't take away from the fact that there's mass attracting mass.
Yeah, it does, because you're trying to draw a conclusion from the experiment, and the experiment on its face is faulty. So, how can you reach a conclusion from an error?
So, if there was no balls there, would there be no acceleration?
How can you reach a conclusion from the error? You're just saying that.
Yeah, I am just saying.
Well, so I got a scenario. What if I had buckets of non-Newtonian fluid, and I filled up the buckets, and that was my masses? It was non-Newtonian fluid, and I stuck them in there. What would happen?
What? Wait. Can you say that experiment again?
A non-Newtonian fluid is a fluid that, when force is applied to it, it gets more dense.
Yeah.
Yeah. So what would happen if I used buckets instead of balls? Buckets of non-Newtonian fluid.
Are you saying that the balls are attracted to it, or are they in the fluid?
This is over your head. Never mind. Let me forget it.
You just need to clarify. I mean, you're not really that concise.
No, it's too complicated.
Okay.
So a non-Newtonian fluid, if there's a force acting on the buckets, then the fluid in the buckets would get denser. It would get harder.
Well, it doesn't come dense. It's shear friction. It gets more viscous under pressure.
Yeah, because a force is being applied to it.
Yeah, and the reason this experiment is a thing is to show the extremely small forces. It's not about the forces.
No. Oh God! Do you know who Professor Brian? Do you know who Professor Brian Cox is? Do you know who Professor Brian Cox is? You don't know who Brian Cox is, the famous professor, scientific guy on TV, gives us loads of programs, right? You don't know who he is. Do you know who George Musa is? Do you know who Neil deGrasse Tyson are?
Yeah.
All right, so these people will declare to you that gravity is not a force. We can think of gravity as a force, but it's not a force. Professor Brian Cox, gravity is not a force. Neil deGrasse Tyson, bending and warping of space-time. Michio Kaku, bending and warping of space-time. Gravity is not a force.
If you're going to cherry pick what they're saying is, so if you're going to... Wait, stop.
No, don't stop me. This is a hostile witness on your side. Your priests say this. The guys who give us the heliocentric model turn around to us on TVs and say, gravity's not a force.
So you're going to believe...
hasn't been thought of as a force for 108 years.
Can I ask you something?
No, because I'm making a fucking statement. They don't think gravity is a force. The people who say gravity is a thing, they don't give you a scientific experiment for it, because they admit there isn't a scientific experiment for it, and it is most definitely not a force.
So you're going to believe one statement Neil deGrasse Tyson says, but you're not going to believe his whole theory of the Earth being round. You're not going to believe anything else he's going to say. You're only going to believe that one thing.
Do you know what a hostile witness is? Yeah, do you know what a hostile witness is? It's somebody from your side that says something that debunks what you're fucking saying.
But he's also saying that the Earth is round.
Yeah, that's fine. Then he would have to demonstrate that with measurements of curvature, something else that is in contention. But somebody who propagates the idea of gravity, a scientist, quote unquote, will turn around to you and educational facilities around the world and say gravity is not a force.
Why do you nitpick what he's saying?
It's called fucking hell. It's a hostile witness.
Let me ask this guy.
Well, what?
Soy boy. So your claim is that these balls move because mass is attracting mass.
Yeah.
Okay. What's your evidence? That's the reason. That's the causal mechanism.
You can see this in an observation.
You can't see the mass, right? So what's the evidence that mass attracting mass is the causal mechanism?
You can literally see it.
What does that mean? What am I seeing?
You can see that mass is attracting mass.
What's mass?
I don't see masses. What does mass look like?
What?
What color is mass?
No, that's not. Oh my god. Oh my god. Elementary.
Yeah, what color is mass? What color? What does it look like?
Why are you saying? What are you saying?
You said I can literally see it, so I want to know what I'm seeing.
You can see the phenomenon. I'm not saying you can see mass.
Yeah, so we want to know the cause of the phenomenon. How do we determine that?
We can determine the cause is because of the bending of space.
And there was us all thinking that you were going to give us
It bends the fabric.
I thought it was a force. What happened to that?
It is a force.
It's not. It's bending the wall in the space time.
Wait, there's too many people talking. What?
Okay, even if you claimed it was the bending of space, how did you determine that's the cause?
There's other factors. I mean, I'm just talking about the mass attracting mass here.
Okay, you're just repeating the same claim is the cause, right? I want the evidence that's the cause. I don't want your claim. I know what your claim is. I want the evidence for the claim.
The evidence is the acceleration between those two masses.
Okay, that is circular logic. The acceleration is the evidence of mass attracting mass, and the evidence for mass attracting mass is the acceleration. That's circular logic, dude.
It's caused by this fabric of space, but we can see it because of the attraction.
We can see what?
We can see the two balls being
together. Yeah, we want to know why that's happening. What the
because of gravity, what we call gravity.
Okay, yeah, that's your claim. That's your claim. How do we determine what the cause is scientifically?
Through other methods, we can assume that if these balls attract each other, then it must be gravity.
What?
Affirming the consequent. Just full of fallacy.
Right.
Isn't what is that one? If it's like if Q then P therefore Q or whatever. It's like that.
Yeah,
if we can prove, I mean, if we can prove, if Q improve,
P, if I'm hungry, then Q, I've eaten 10 hamburgers. Sorry. Oh, fuck, I always get this the wrong way around, the P and Q fucking formulation. It's really hard. But ultimately, when we're talking about this, you're just circling one presumed cause when there could be a multiple of things. For example, when somebody says that they're hungry because they've eaten 10 hamburgers and that they're hungry and the only cause of that can be 10 hamburgers, then you realize they could have eaten pizza or Chinese or anything like that. Something else could have caused the phenomena to happen. When we're affirming the consequent, we're just saying that because the phenomena happens, it's just because of the cause that I fucking assert to be and forget about everything else, which is why I was on about you and your control variables earlier, which you didn't want to give me.
I did give you.
No, you didn't. You didn't even mention the gravitational pull of the sun or the moon, the electromagnetic field or influence of the earthly environment around it or anything like that.
That's because you didn't ask me.
I asked you what your control variables were.
We don't even need an alternative. You have to prove your proposition. We don't have to disprove it. You say gravity, mass attracts mass, is the causal mechanism of the balls moving. Demonstrate it. How do you demonstrate that? With a scientific experiment.
Yeah.
I can demonstrate it if you wanted to. It might take a while, though.
With a scientific experiment.
I'll set up a hypothesis. I'll set up control variables, independent variables, all that.
Cool. So what will be your independent variable? What's the phenomena you think you're going to try and find the cause of?
My phenomenon will be mass attracting mass, their gravity.
Your phenomena will be mass attracting mass. What's the cause of mass attracting mass?
The warping of space or the curvature of space.
Awesome. So you must understand that your independent variable is the curvature of space-time. But that's not physical, my friend, is it? Space is the
That is, actually. You can do that with the differing masses. The curvature of space-time is directly proportional to the mass.
Hold on, these are aspects, mate. These are not actual physical things. You're talking about space with the absence of anything, so not physical. And time, well, I'm really going to enjoy you not painting it red and you not putting it in a jar for me. These things have to be physical for you to vary and manipulate.
So you can't see the air, but can you manipulate the air?
Do you understand that space-time is a reification, as in not actual things?
So you're saying there's no such thing as space-time?
Yeah, it's a reification. It's a not actual thing.
Concept.
Okay, then.
It's a concept.
That's what you want to think.
It's a mathematical concept.
It's not what we think. It's what reality is. It is a concept in the minds of men. It doesn't exist. Okay, did it exist prior to someone thinking about it?
Probably. Or no, probably not.
Okay, then there you have it. Probably not. Whatever. That means it's a bullshit. Okay. You can't even make a statement about it. You have to make a statement on each side, which means you said nothing, basically.
Oh no, I meant to say like I was there before, and then I was trying to say I wasn't.
Awesome. Are you going to be able to give me space time then? Can you pass it to me? Can you send it to me?
Everywhere. Space time is a constant. It's everything. Everywhere. Space is the medium.
Brilliant. Then give it to me then. If it's everywhere, give it to me.
It's already everywhere.
Well, give it to me then. And say it's already there. Well, brilliant. Give it to me then. If it's already there, give it to me.
It's already given to you.
Give it to me and paint it red.
What? So can you paint air red?
Pardon? Can I paint air red?
That's.
I can do shit with it and change its colour. Yeah, but I'm asking you to give me space time. Give it to me.
So a magnetic field. What about a magnetic field? You can't see a magnetic field.
I'm asking you about anything else, and you're going to say things that you can't give me. That's fine.
We have limitations. We have limitations of seeing, but we can prove.
What is time physical?
Time it's not a physical thing, no.
Oh, okay. So being as we're doing science, the physical and natural world, and we've definitely got to be able to vary and manipulate our presumed cause because it's physical, then we're not going to be varying and manipulating time then. Awesome. So space, absence of anything. Can you vary and manipulate nothing?
You can add air to it. When I say space, I'm not talking about a vacuum. I'm saying...
Space-time. Yeah, that thing. Not talking about the vacuum, but I'm asking you about the space bit. Space, the absence of anything. Can you vary and manipulate, make something happen to absence of anything?
You can manipulate the fabric of space by having a massive object. Okay, a massive object will curve the space-time.
Hold on. I get what you're saying, as in your statement, but it's up for debate at the moment because these are non-physical things. Space-time, reification of joining these non-physical things together. Not physical, it's a reification. You're not going to be able to give me time. You've already admitted to that. And nothing. You're not going to be able to give me nothing now, are you? Here's nothing. Go on, very manipulate nothing for me. Oh, brilliant. So in your scientific reified space-time, you're going to need to vary and manipulate your reification of not actual fucking things.
When I say space-time, I mean like the fabric of space. Like, what is like space?
Give me the fabric.
The fabric? It's just described as fabric. It's not actually fabric. Like, you can see... demonstrate. What?
So it's not fabric then, it's just described as fabric, so give it to me so I know what it is. It's not
you guys even have demonstrations of this. I mean, you guys post stuff. I'm trying to find one in the chat. It's like, massive. Have you ever seen a black hole, like the density thing? Like, it's just a visualization of it.
Yeah, it's a visualization, but it's not the actual thing now. I'm asking you for the actual thing, not a visualization or a concept based on the idea. I'm asking for the actual goddamn motherfucking thing, my friend. The thing that has to be varied and manipulated as your presumed cause of your effect of mass, apparently, or whatever bastardized version of a hypothesis you're going to attempt to give me again. Mate, I'm trying to help you.
Don't even say that, because that's not even true.
It is, because you're uneducated. I'm trying to help you trying to help you change your mind, because it is not correct. When you hold a standard like the scientific method to things, you must understand that Cavendish doesn't follow it. When you're going to give me things that are not actually real and then tell me that they are actually real, my friend, come on. Time is not a real physical thing. Nothing is not a real physical thing. You cannot sandwich these two things together and say all of a sudden they're a fucking fabric. But it's not a fabric. It's just described as a fabric. I want the actual thing then. Do you understand?
You can't hold it.
I'm pointing out to you, right, as a mirror. This is what you're giving me, and it's ridiculous, my friend. Please think about what you're saying. We've been doing this for 2 hours now, but you're belligerent. You want to die on this hill because of a belief, and it's taking all of us with big slaps around your fucking face to try and wake you up. Sorry if you're taking this the wrong way, mate, but we are trying to help you.
it's impossible to hold space, the fabric of space. It's not.
Well, then you can't use it in a scientific experiment. It's not manipulatable. It's not. You can't manipulate it. Then you can't vary it. It's not. No, you can't. It's not physical.
By something having more mass, something being more massive, you can manipulate the fabric of space by bending it more. That's a consensus. That's a consensus.
Okay, so I've got a bowling ball. Where's the space-time fabric bit that it's bending? Where's the physical interaction? Where's the physical interaction that you're talking about of this fabric that's not a fabric?
It's not a physical interaction. It's just it's like you have to conceptualize it. It's not like a physical thing.
So it's an idea.
Like magic. Science. So outside of science, where we're trying to deal with the physical natural world, you're just going to give me fucking concepts. Do you understand yet? No. Science deals with the physical and natural world where we have a physical phenomena and we have a physical cause, and within the experiment we physically manipulate what the cause is of the effect. You're giving me concepts. It's interesting, right? Because that's what space-time is. It's a mathematical concept. It's not fucking science.
So is buoyancy a concept?
And I vary and manipulate the things like I explained to you when I had an egg and some water and changed the density of the water and the egg rose.
So that's not a concept. We didn't make that up. We didn't make buoyancy up.
We made words. We make words up to describe.
So we made words up to describe space-time or fabric.
So the physical interaction, the water, the density change because I've added salt into it, and the physical phenomena of the physical egg rising, all those are physical things. I've physically interacted with them. Are we going to go round a space-time fucking merry-go-round again where we admit that this isn't physical and you're going to say it's a concept again?
We can interact with it. We interact with space-time all the time.
Oh, all the time, but we don't fucking see it.
We interact with it.
We interact with it, but where is it? You just declared that it's there. This not actual thing. It's not an actual thing.
It is.
It's time that we can't vary and manipulate. This absence of space that's nothing. This fabric that's only described as a fabric. We're physically interacting with it. Have you got special eyes or something, mate?
We interact with it. We can see it because of gravity. The Earth interacts with it. The Earth pushes it. It makes a bigger, kind of divot. I guess you can imagine it in the space fabric. We interact with it.
According to your story and belief, yeah, because you think you're on a spinning ball flying around in the vacuum of space.
Are you mentally retarded?
Whoa, that was kind of insulting.
But what we're going to do is we're going to get down to the base claim. Hold on, my friends and everybody else. We're going to get down to the base claim. We're going to get down to the base claim because it doesn't matter if you're talking about mass attracting mass or the bending and warping of space-time. In every single calculation, you've got a letter of the alphabet, and that letter is R. That is the radius of the Earth. So whichever gravity that you're talking about within the calculations, you've got an R. You know, Cavendish trying to figure out the weight of the Earth, which was a ball, and the ball sitting in warping, the bending of space-time, that R value. So have you got a direct measurement of the R value?
Well, the R in this, I don't know the R in this thing because I haven't made up the experiment right now. I think the R is the R the if R then P, or is it if R then Q?
Radius of the Earth, 3,959 miles. We need a direct measurement of the Earth that is in all of these calculations to make these phenomena happen. So if you've got a direct measurement of the radius,
24,809 miles or whatever.
Yeah, that's the circumference. I've given you the radius. We can double the radius to get the diameter. What we're looking for is 8 inches per mile squared of drop over distance. Is there a direct measurement of that anywhere?
8 miles per. I don't really understand what you're trying to ask.
I'm asking you for a direct measurement of the curvature of the Earth, which is said to be a ball in all of your gravitational ideas. You need the Earth to be a ball for all of your gravitational equations. So have you got the R, direct measurement, not calculation?
Of the curvature of the Earth?
Yeah.
No, I don't have the exact value.
No, not the exact value. I want to know how it was measured to be true in the first instance.
I don't know the first instance. I don't know how they measured it the first time, but I do know they measured it.
You do know that they measured it, but you don't know how. So it's just a belief that you got, right?
No, because how would they be able to launch a rocket or ISS without knowing that?
Hold on. You've just given me that it's a belief. Even though, yeah, you need the R value first.
Yeah.
Before you go into space to fly around the R value, the radius of the Earth, you're going to need to know how fucking far you're traveling, right?
Uh-huh.
Awesome stuff. So before we go to space, we need to figure out how big the fucking ball is. So how big is the ball? 3,959 miles. Awesome. How is that directly measured to be true?
I don't know how they measured it. I don't measure the Earth.
Awesome. So you just believe that it was done, don't you? Just like you believe there's a scientific experiment for gravity. You just got a lot of beliefs, my friend. You've got no first-hand knowledge.
Belief. It's based on science. It's based on measurements.
Well, it is a belief if you don't know who did it or when they did it or how they did it. You just believe it is, so it's a belief.
I know people have done it. I know people have. I'm not saying like none of no
then
people.
If
no one has done it,
buddy?
then it would be a belief.
If you knew,
It is
then
a
you'd
belief
be able to
because
tell
you
us
have-
who and how.
Yeah, give us the name of who did it.
I don't know who measured it,
Oh,
but I
then
know
you don't know it's a belief, buddy. Come on.
Instant double speak then. He just said that he knows people who have done it. Then he says, well, I don't know who.
I'm saying I know that people have. I don't know who.
Yeah,
Can you guys
you
understand
know that people have. Oh, but you don't know who. So then how do you know that people have?
Because it's pretty obvious that people have. If they're going to launch something into space, then they would have to know how big the Earth is.
Yeah, they would. So how do you know that they've done that?
You can see rockets take off and go into orbit.
No, you can't.
Yeah, you
No, you
can.
can't.
Space, bro.
No, you can't.
They never went to space, bro.
What do you mean they never went? Where do they
The
go?
vacuum of space can't exist, buddy. So you're going to have
You're
to
gonna need
verify
that.
everything you keep saying. You're just stacking claims on top of other claims that you haven't verified. You even admitted you don't know.
I don't know who measured it, but I know people have.
No,
Yeah,
you
how do you
don't.
know that?
You
How do
just said that you don't know.
Yeah, how do you know they've done that if you don't even know who they are? You don't even know who you can point to or what you can say that they did. So how do you know they did it? That which you don't even know.
If I'm NASA and I want to launch a rocket or I want to launch the ISS into space, I need to know how big the Earth is. I need to know the rotation and all these things.
Yeah.
So it would make sense for me to measure it.
Yeah, so someone is going to have to have done that in the first place. So who did it?
I'm sure NASA has done it. Because they would have to know.
Provide us with that.
Until
They
we
would
ask
have-
you what they did and who did it, and then you have no idea.
It would be pretty obvious that NASA did it if they're going to launch something into space.
Okay, then go get us the measurement from NASA.
I could try to find it, but I'm sure it's saying that they haven't done it because, like, if can you guys not see that if I was going to launch an ISS into orbit, I would have to know how big and how much it
It's a derivative claim. It's based on your primary claim of the radius. So that has to be established first before you can go to anything else after that. Anything based on that is irrelevant and invalid until you can provide the first order primary proof for the radius it's based on.
So is your claim that the Earth cannot be measured?
Literally, nobody made a claim.
I'm asking.
You're
is
the
it your
one
claim?
making the claim.
I'm
You
asking,
keep
is
saying
this-
you know, but you don't know.
Is this your claim?
Yeah,
No,
we've
I'm
measured
asking-
the Earth. We've measured the Earth. The waters are flat. We're asking for measurement of curvature. Yes, the surface of the Earth can be fucking measured.
Okay, so it's possible that the Earth's circumference can be measured.
Supposedly, who did it?
I'm asking you guys.
How do you know there's a
Sorry, be
circumference there to measure?
Yeah.
What was that?
We're looking for drop over distance, not going around in a circle, right? That's circumference. Yeah. So drop over distance. You know that you know a beach ball or a basketball. You put your finger on the top, right, and then you put another finger anywhere else lower down. Between point A, your first finger, and point B, your second finger, point B is descended from your first position at point A, right? The consequence of being on a curved surface is going to be curvature between 2 points, isn't there?
Yeah.
Yeah, awesome. So we're looking for that then.
Well, I mean, I've just This is by NASA. They say they use GPS and other GPS satellites to measure the Earth.
They
You're gonna
use
need that
GPS.
first. You're going to need that
GPS
first
satellites.
Yeah, you need the measured radius beforehand.
Yeah, they measure the Earth, and they can get a more accurate prediction from space.
From space, which is the second law of thermodynamics violation.
It's not.
A decrease. It is a decrease in entropy. You haven't proven. Hold on. You haven't proven gravity. Go round again, and you still don't have the phenomena of gas being attracted to fucking masses. Being the first instance, gas goes away from the mass and exists in the space away from the mass. But you can't keep saying that they have gone to space and measured the radius of the Earth because they needed to know the radius value of the Earth before they went into, quote unquote, the fucking sky vacuum, apparently. So we need the first measurement of that. It's interesting that you're not being able to provide it for us because there isn't one. You just believe that there is.
I mean, there's multiple methods. Like, I think Eratosthenes was the first, and he used shadows in a well. But there's
What gave him the inkling that it was a ball to be measured in the first place? Because it seems to me like you're just doing what he did. He assumed that the Earth was a globe, and then inferred it, and then measured shadows.
So why does it matter if he originally?
Because it's all based off of assumptions.
What he has is sorry, Kim. Yeah, sorry about that. What he has is an inference of a radius, not a measured radius. He doesn't have a measured arc segment, any measured drop over distance. He's just assuming those things are there and then extrapolating them from something else that has nothing necessarily to do with that, i.e. shadows. That's what he actually measured. Shadows. We're asking you for the direct drop over distance measurement.
If Eratosthenes measured this and his measurements didn't add up to what his assumptions were, wouldn't you say that the Earth is flat then?
Stop. Measured this. What is this?
The size of the Earth. The circumference.
No, that's not what he measured. What he measured was shadows. He extrapolated the size of a sphere that he would have if all of the assumptions that he made in the first place are true. Right? So that's not what we're looking for. We need first order proof of the thing that he's assuming and then extrapolating a size of in the first place. So that would be a direct measurement of drop over distance, not a direct measurement of shadows and then an extrapolation of drop over distance from those.
Well, in order to measure the circumference of the Earth, you can't measure it all at once. You have to use shadows and quote-unquote extrapolate.
I said that's a straw man, so that's why I said arc segment. I didn't tell you to measure it all at once.
But you'd need to measure some part of it to...
Yeah, that's what I've said for a third time now, an arc segment.
A drop over distance.
Who done it?
Who? Eratosthenes. Didn't he measure the Earth's curvature?
Oh, boy.
He did not measure curvature of the Earth, buddy. He measured shadows.
But doesn't that, doesn't his measurements add up to be curvature?
Imply. So you're talking about implication. So, like we said, that's implication or inference. We're looking for a direct measurement because that's the only way you're going to confirm it.
That's right. Direct confirmation of the thing that he inferred.
So
otherwise, how do we know that what he's inferring is even there?
So you're saying his shadows can't be accurate. So then what would be accurate? How could you do that?
No, that's a straw man. I didn't say the shadows are not accurate. They are what they are. What he's interpreting from them is not, obviously, since it can't be directly validated.
The assumed ball needs to be validated. It can't just be assumed and then just, the assumption's just what we accept. It needs to be verified. Do you get that?
So
you can't just assume and then not verify your assumption.
So in order to prove that the Earth is a ball, you can't assume that it's a ball?
Don't assume anything.
Bro, if you want to assume that sea level is curving, then you be my guest. You can assume that sea level curves as if words don't have specific meanings, but that's all right. Back to you, Platzy.
I'm just over here about to bust a gut laughing at this guy because he just doesn't seem to get it.
No, it's not a good idea that you beg the question, right? Eratosthenes begged the question. That's when we say he thought the Earth was a ball. And within his calculations, He used mathematics to assert that the shadows were given the consequent of a ball. Don't be surprised when at the end of his mathematics he ended up with a ball. It's not proof of either way, because you know that you can stand in your kitchen underneath a light and only have the shadows underneath your feet when you lift them up. But then you walk away and you watch the shadow increase in front of you. If you were to assume that your kitchen's a fucking ball and use the mathematics associated with that, you can literally turn your fucking kitchen into a sphere.
So are you saying that his calculations... So how do his calculations, if it was a flat plane, wouldn't they contradict his idea of it being a ball?
No, because he assumed it to be a ball in the first place. So therefore he used the maths to come out with a ball. Guess what he got? He got a fucking ball. Yeah, you can walk away from a light source on a flat plane and watch a shadow increase in front of you. What's that going to prove?
Yeah. He hasn't shown the globe in reality. He's just assuming it in the maths. He's solving for a circumference that's never been demonstrated to begin with. He's just assuming it's there.
Well, we can see curvature from the ISS, though. Like, that's just... You don't even need to measure anything. We can literally see it.
You shouldn't. That's a problem. Geometrically, 250 miles above a ball with a radius of 3,959 miles, you should be seeing about 3% of that ball's surface. You shouldn't notice a curved horizon. If that's what they're showing you, then that's bullshit.
Well, if we only see 3% and we can see the edge and it's not a giant ice wall, then we can assume that it's not flat.
There's not only 3%. What are you talking about? The whole Earth, and only 3% of it wouldn't show you that much. Think about what you're saying before you say it, buddy.
I'm saying that... 1 second, let me pull it up. So there is this 50-minute ISS tour, and it's...
No, you can drop
you can see the curvature. You can see the haze of the... Huh?
We already dealt with this. Geometrically, you shouldn't see any curvature, so if they're showing you that, there's a problem there. And also, you need the measured radius to have satellites in orbit in the first place to derive the orbital mechanics of the ball. You need to have that radius in place first, so you're trying to jump off of the primary claim and go to something derivative again. We're asking you for the direct measurement.
Yep.
So, are you saying that I've posted a picture in live stream voice chat? Are you saying that that's not curvature? I mean,
Are you talking about a bendy horizon, or are you talking about drop over distance?
Drop over distance. The curvature of the Earth.
Oh, so how do you measure that from a photo?
You can see if in the flat Earth model there would be a ice wall, and you can clearly see that there is no ice wall.
That's a great straw man, but so what's the radius of that ball that you're showing us in that picture? Because that looks a lot smaller than the one that you've been in here arguing for all this time with sticks and shadows.
The radius of this one is around 3,000 something. The radius of the Earth.
Oh, really?
3,000 something.
Yeah, 3,959. I shouldn't be seeing any curve, let alone that much from that height above the surface of that ball. So you must be a tiny Earther. You must believe in a way smaller ball. Like maybe you think you live on the moon or something. I don't know.
Then what would this be then?
A fisheye lens, wide angle lens.
But it's not. If you watch the video, there's no distortion whatsoever.
Let's watch the video. Link it.
Please show us that there's no distortion.
I'll give you the link. So it's a flat.
That's a burden of proof reversal fallacy anyway. It's a burden of proof reversal fallacy.
So
it's not up to us to explain what you're showing.
So
your priest has told you differently. They tell you that you can't see the curvature of the Earth from that height anyways. So we can just move on.
If you're looking straight at it, but again, you're looking at an edge, you're not looking straight down at it. If you are looking straight down at it...
So we're looking at the edge. I thought you said it was drop over distance we were looking at, not a curved horizon.
It is what are you trying to... What?
So what's the claim? Is your claim that the curvature is representative? Are you claiming that a horizon is representative of Earth curvature?
I don't know what you mean by that. I'm just talking about a sphere. I'm talking about just a sphere.
So wouldn't that be the horizon, the edge that you're talking about?
From up there? I don't even know if you call it a horizon.
Well, that's what the horizon is claimed to be in the globe model, quote unquote.
Well, I don't really know. I'm not sure about that. Well, have you guys looked at the video, or it's
well, what's the definition of a horizon?
I don't know the definition of a horizon.
Where the land and or sea appears to meet with the sky?
Yeah, that would be a pretty sound one.
Right. Well, that's what you're seeing, right? In that image.
What the sky is space. It's not a sky in this example.
Oh, it's not.
Hey, yo,
it's not sky. Are you kidding
yo,
me?
Hubba Bubba Soy Boy. I mean, like, here's the important question, though, which, have you figured out what the difference is between pseudoscience and physical science is yet? That's like, really important.
Well, I think I know the difference.
Okay, please explain to the class.
Science is...
Right, because I told you 5 times earlier.
What? I'm just trying to explain it.
Good.
All right, let him explain it, Jedi. I just want to hear this. I probably wasn't here for it. Let him explain it.
Pseudoscience is not real. It's not something that is... It's just not real. Like, it doesn't exist. Like, if I were to say, this crystal transmits energy through this copper wire and disables your phone, and you'd be like, what the hell are you talking about? That's incorrect. There's no science backing that up.
That's not it, buddy.
I'm giving an example.
If you couldn't tell by the giggling, it's wrong.
It's kind of a weak example. It's kind of a weak example. Okay, can I just lay it out for you? Because I have, over the past 7 years, I've had to learn the difference between pseudoscience and physical science. And pseudoscience is simply made up of a series of hypothetical ideas which cannot be proven observably in reality. Okay? That's the difference between physical science and pseudoscience. Pseudoscience cannot be proven in physical reality. They are just hypothetical ideas. Physical science is something that is observable, testable, verifiable, repeatable. Can you observe gravity? Can you observe mass attracting mass? If you put one rock next to another rock, is it going to become one big rock?
That's a little, there's a little dramatized a little bit, but...
No, it's not dramatized.
It is.
Simple. I'm putting it in the simplest terms, my brother. I am putting it in the simplest terms. If you put one rock next to one rock, do those two rocks become one large rock because mass attracts mass?
If you put two masses close enough together, they will exert a force.
But if I put one rock next to another rock, they're literally not doing a fucking thing.
That's because the force is too small. They're not massive enough.
So gravity is selective then?
No.
Gravity sounds like a picky bitch. I'm just going to put it out. Gravity sounds like a picky bitch, brother.
Okay.
Gravity picks and chooses what it does and doesn't affect. So you've got a gravity that's... Hold on, I'm not done. So you've got this gravity, okay, that I've heard a lot of globe believers invoke as the containment for Earth gas pressure. I've heard a lot of globe believers invoke gravity as the reason why for their spin or whatever. Okay, this isn't working. Okay, you've got gravity going in two different directions because of this pressure gradient. You have a gas pressure gradient because various gases have various densities, my brother. Okay, and there is no vacuum. You cannot have a vacuum adjacent to a pressure system. Mass is not attracting mass. Take gravity out of your vocabulary, and what do you have? You have relative density and you have relative buoyancy, my brother. And that just means that there are different mediums in which these things flow or float through. Yes?
Kind of. So I've let you speak.
Okay.
So I'd like to speak for myself. So gravity and the buoyancy thing, like you can have a high pressure system next to a vacuum. Vacuums in space don't suck. They don't exert any force on the atmosphere. The only force that they exert is in an atmosphere.
Demonstrate this claim.
The only way you can have a open system next to a vacuum is with gravity, mass attracting mass.
Demonstration, please.
My demonstration is the orbits, the ISS orbit.
Demonstration. Guys, please, I'm gonna have to jump in again because it's like he never listened to a fucking word I said. You do remember about our conversation about vacuums and they don't suck. No one says vacuums suck. The energy comes from the gas that's moving freely and randomly in all directions, and the vacuum is absence of anything, so there's nothing stopping the gas from dispersing into the vacuum.
Gravity is.
Entropy is in action. Now, if you're going to say gravity again, I'm going to fucking remind you don't have a scientific experiment that proves you one, but I'll tell you what, I'll give it to you. It doesn't seem to be affecting the gas because that's moving freely and randomly in all directions, and you drop something and that you declare gravity to be. So you don't have the observed phenomena to start your science with. You're talking about a violation of a law of nature. You're talking about an entropy decrease, where entropy increases. In this instance, the high pressure will disperse into the lower pressure environment. I don't want you to not be educated when you leave here. I walked away and I let Jenna talk to you about the the pseudoscience. You didn't seem to fucking understand that, and I went through with you earlier. I've just gone through this with you again, only because you said vacuums suck, and I corrected you on that earlier. It's like you haven't listened to anyone.
I never said vacuums suck.
Oh, he listened to Professor Dave, apparently.
So I agree with you in the sense that if there's no gravity, an open system cannot be next to a vacuum. I agree with you on that, but there's one thing, is that the gravity is holding the air or the atmosphere to the ball. I mean, like, the gravity is mass attracting mass.
Do you know what inverse square law is? As in, the further away from mass, gravity decreases. That's a fucking problem, being as you've got gas up there. So what's stopping the gas from dispersing into the vacuum of space, being as that's where gravity's weakest? Being as gravity's strongest down here, I remind you about where the gas is produced, carbon and biological cycles on the surface of the Earth, so where gravity is at its strongest. And guess what it does fucking down here? It moves freely and randomly in all directions and moves away from the mass. You don't have the observed phenomena of gravity acting on gas. Like I said, I can give it to you, but scientifically you haven't got the observed phenomena to assert a cause to.
The farther away you have from a massive object, the less gravity there will be, but that doesn't mean that it will float away. That just means that there's less attraction, so that it will stay up there. Like, it can be in...
I'm sorry, that's not...
where the gravity is strongest, down here, where the gas is produced, the gas is moving away from the mass in the first instance. So stronger down here, and it's moving away and not affected by gravity. But you say up there, where it's further away from the mass, there it starts taking effect to the gas, and it starts pulling it back. Are you fucking stupid, sunshine?
That's what I said. Well, you can stop with the insults. You don't have to insult.
I do, because you're being really silly and we're wasting an awful lot of time on this. Do you want me to go through it again? I will, no problem. Gravity gets weaker away from the surface of the Earth. Gas down here is moving freely and randomly in all directions and filling every available space. Up there, where gravity is weaker, you're saying what? That it stops the gas now, where it's weakest, where it was moving freely and randomly next to the surface of the Earth, where it was strongest. Now
there's still a pull.
There's still a pull, is there? Where's that? Where's the gas coming back?
Pull?
Where's the gas going? Where? Show me.
The pull is from
the water cycle. What about the water cycle?
What the heck does a water cycle have to do with the gravity?
Because when the hydrogen bonds are broken in water, which way do they go?
They reach equilibrium.
No, which way do they go when water evaporates, buddy?
They reach equilibrium. That can be up, down, or whatever.
Buddy, you're avoiding the obvious elephant in the room.
If you want to say it goes up.
Which way?
Up. It goes up.
Exactly. So where is your vector down? Gravity.
The vector down is gravity, yeah.
What?
The buoyancy to reach equilibrium can overcome gravity only to a certain point.
No,
a hydrogen balloon can only go up so far before it reaches equilibrium.
Why can't you respond what Jedi said, though? About the week?
I must have missed it.
Like, the gravity being stronger next to the Earth, for some reason it doesn't bring down the weak gas, but then somehow it happens all the way up there in the sky when the gravity's weaker?
It has more of a pull near the center of mass.
Yeah, well, why does the water go up?
Buoyancy.
Buddy, you are just a double-speaking snake.
Well, what do you mean? What do you mean by that? Why am I double-speaking snake?
Because you just said that when water evaporates, it goes up, but closer to the surface of the Earth, everything is being pulled down.
Everything is
no,
relative.
not everything is. So where's your gravity?
Everything is being pulled. Huh?
Yo, soy boy, hubba bubba boy, hubba bubba soy boy. I mean, you evidently have never seen rain in a jar show. Like, you don't know shit about terrariums and it shows, bro.
What are you talking about?
What is this person saying?
Breeze, what are you trying to say?
What are you guys talking about? I'm sorry for just like cutting in.
Oh, so
you cannot. Okay, all right.
Derivative
Let
claims
me
that
clarify.
reified the sphere radius that he can't show a measurement for in the first place. And so let's just go back to that. Where's the direct measurement? Because everything else you say is based upon that. It's all derived from that, right? So let's just go to the first order proof that substantiates literally the entire paradigm that you're arguing for. We don't need to waste our time in the weeds.
So what do you want me to give you?
I want a direct measurement of drop over distance of the Earth's surface.
Isn't it like 8 inches per mile or whatever?
We already know. Parents, if we already know that there's miles upon miles of
shut up.
curvature.
We want to answer this question. We want a measurement of drop over distance, please.
That's what we want. Everything he says is based on that, is derivative from that primary core claim that he has. So that's what we need.
Right now, I don't have a measurement because I don't have resources on me.
Okay, no measurement. So you can just shut up then. Because, like I said, everything else you say is based upon that, right? That would be the primary core claim that basically everything else you're saying is based upon. So if you don't have it, just be quiet. Yeah, until you get it, just fuck off.
What?
Yeah, just fuck off until you get it, right? Because you're just delving into the weeds. You're just wasting this panel's time with derivative nonsense, fairy tales, fantasies, pseudoscience, all based on the claim of a globe radius that you just told us you don't know how to provide any measurement for.
Oh, I know there's a measurement, I just don't have it on hand.
Oh, how do you know it's there if you don't have it?
Because there's Earth curve calculators and stuff like that.
That's cool. I can put numbers into a calculator and make one too. Doesn't mean it's based on anything that actually exists in reality. I can make an Earth curve calculator for a hypothetical globe Earth with a radius of 500,000 miles if I wanted to. Doesn't mean it's real. That's a reification fallacy.
So even if I were to give you a measurement, you just say it's false?
No. I would say
fine, fine, I'll say it's 1 inch or 1 inch per mile. There you go.
Stop appealing to future.
Not the calculation. We want the direct measurement that asserts that the Earth has a radius of the set value. We need the direct measurement first.
Of the radius?
Yeah.
Oh, the radius is like 3,900 feet, something like that?
3,959 miles. We know the associated values. We want the direct measurement of those values.
But that is the measurement. What do you mean by direct measurement?
As in, how did you come up with those numbers in the fucking first place, you idiot? Did you measure them?
No, I did not. I didn't measure those. I didn't put those measurements out there, obviously.
Excellent. So somebody must have measured them for them to be in the calculations. And the calculations are based on reality. They must be based on a direct measurement of that reality, right?
Yeah.
Awesome. So we need a direct measurement of the R value of the Earth then, don't we? Before we can even suggest we can put it into calculations for shit, right? So when's that been done and how was it done?
Didn't Eratosthenes do a curvature?
Oh my god, are you respawning?
It's literally having the same conversation with the same guy 5 times in the last 2 hours. We're just going to be talking about lights in the sky and walking away from them and increasing shadows. Assuming the Earth to be a ball, using the calculations to get a ball, not be surprised when we get a ball at the end. Shadows don't prove anything because you can have shadows on curved and flat surfaces, you idiot. So not Aristosthenes, and he didn't measure drop over distance. This is the circumference value of the Earth. This is why you should pay attention to the question. Drop over distance, please.
I'm just 1 inch per mile. There you go. Because it doesn't seem to matter what.
That is a value again. You just keep doing this. You just keep giving us values. Not even the correct one, but you're just throwing a value out there when what we're asking for is the measurements that were used to arrive at those values. So what you're doing would be like, what if I came in here and said, I'm 6 feet. Okay, how was that measured? 6 feet. No, give me the method of the measurement. 6 feet. That's what you keep doing.
He's exposed. Everything about anything he's brought up has been exposed. You're exposed.
What do you mean exposed though? Like
He's exposed as a fraud.
You're
How
right,
is he a
Tim,
fraud?
sorry.
Like,
Sorry, my friend,
I just don't. Like, he seems like he's genuinely trying to understand.
Listen,
We should, like,
don't
explain
interject.
things,
Listen. You'll understand more about the conversation if you listen. Did you hear what Heretic said to you? You can't just make declarations that you're 6 foot without a direct measurement. How do you know you're 6 foot? I'm 6 foot. How do you know the radius of the Earth value gives radius of the Earth's value? Have you got a direct measurement for it, mate? Can you prove you're 6 foot with a measurement, please?
Yeah, I don't know how they measured it. It's measured though.
You can't know it's measured if you don't know how it was done.
There's a measurement, so you'd have to measure it somehow.
Okay, get us that measurement then.
The direct measurement or just the measurement?
Direct measurement.
Okay, you should clarify that next time. I already said I don't know the direct measurement.
Then don't say you know that somebody has it.
But it's been done.
Don't say it's been done if you don't know who did it or how they did it or what they did.
I can go on a little Google search if you want.
Okay, go on that and then get back to us. And just shut the hell up in the meantime because you don't have what we're asking for otherwise.
All right, I'll come back.
Audacity. Oh.
Tags! What is your profession?
See, old friend, I brought more soldiers than you did.
Tags! What is your profession?
See, old friend, I brought more soldiers than you did.